Alright guys, you are welcome to this live class lesson. Alright, if you are online, do well to signify so we can start right away. Alright, do well to signify so we can start right away, guys. In the course of this live class lesson, I'll be revising the subject chemistry alongside the subject biology. Alright, so as we solve questions in chemistry, we also do the same in the subject biology. So if you are online right now, do well to signify so we can start right away, guys. Alright, so we can start right away. So let us start with the first question. Meanwhile, for those writing the JAMB exam 2026, your exam is starting tomorrow. I believe you are aware about that. Alright? So, the exam is not a tough exam. All you have to do is to calm down and that's why this class lesson is going to be a revision class where I'll be solving likely questions that you need for your exams. Alright? So please calm down as we start right away. Alright? Calm down as we start right away, guys. Alright? So let us start. Let us start right away, guys, with the first practice question we are going to be trashing in the course of this live class lesson. With the first question we'll be trashing in the course of this live class lesson. So if you're online, do well to signify and also share the live class with your friends so we can start with the first question I have here. Alright, so we can start with the first practice question that is here, guys. Alright, so let us start right away now. Share the live, and also, do it to like the live as well. Alright, share the live and like the live class as well. So let us move further. Guys, like the live and share with your friends. So we are starting with chemistry. So we are going to write the question with the options, then we are going to tackle it together. Because these are likely questions I know that you'll be seeing in your exam tomorrow. Alright, so here's the first one. It says, for a general equation, everybody pay attention. For a general equation, I'll be writing the equation on the board of the nature. They now gave us the reaction, alright, and here is the reaction. It says X, P, alright, reacting with Y, Q, alright, with this sign. Whenever you see this sign in chemistry, it simply means the reversibility sign. Alright, so this is the reaction. So now give us Mr, alright, Mr plus Ns. So the question now says, the expression, because these are likely questions and they are very easy. We are starting with this. The question now says, the expression for the equilibrium. Alright, the expression for the equilibrium constant. The expression for the equilibrium constant is, that is the question, and let us tackle the question together. Guys, do it to signify if you can hear me. Alright, do it to signify if you can hear me. So let us trash this question together. And the question says, for a general equation of this nature, you are going to see a likely question like this. It's a very popular aspect in chemistry. First of all, whenever you see a topic in chemistry, it is very vital for you to know the topic to which the question is from. Whenever I say question, all right, this question is from the topic in chemistry called chemical equilibrium, specifically focusing on you understanding what they call equilibrium constant expression. That is what this question wants us to write for. Everybody pay attention. And in chemistry, equilibrium constant expression is symbolized as KEQ, and it has a concept. Actually, this equilibrium constant expression, it could be of two types. We have what we call Kc and Kp. Just relax, alright? The equilibrium constant expression could be Kc or also what we call Kp. What is Kc? Kc is called, this K is equilibrium constant, alright? Equilibrium constant expression, and this C is concentration. This K is equilibrium constant expression, and this P is partial pressure. Just pay attention. So the question is just asking us generally to write the equilibrium constant expression for this reaction, and there is a format to follow. And what is the format? It is simply this. I'm about writing. It has a formula or a concept, and it is simply product over reactant. All right. What is called product over reactant? Guys, pay attention. So you look at your reaction. We have two sides. These are the product side, and these are the reactant side. So you now come here and say equilibrium constant expression, which is KQ, generally speaking, which could be those guys there. It has a, what is the product? The product should be up. And these are my products. Listen, you know, this is not a standard reaction. It's just a reaction that is made up of letters. Alright? These are not elements. Are you there? So, you know, in a normal reaction, let's say for instance, a reaction that deals with maybe hydrogen gas reacting with oxygen gas to basically form water, for instance. Let's just basically form water, H2O, and let us balance our reaction. Here will be 2, alright, and also here will be 2 to make our hydrogen at the left 4 and hydrogen at the right 4. 2 times 2, 4, and 2 oxygen at the left and also 2 oxygen at the right. So now listen very well. These numbers standing in front of these elements, they call them the coefficients. Are you listening? Just pay attention. All these numbers you are seeing, you know, when you don't see any number standing in front of an element, there is an invisible one. Are you paying attention? So what we simply do here, just note that all of these letters that are standing in front of the elements, they are the coefficients or the mole ratio of these elements, because we need them very well. Just pay attention. In my product, my main products are S, arrow and S. Are you there? So for my product side, I'll have the first product is arrow. You write it. Whatever number is standing in front of the arrow or letter should be raised as the power. But before I do that, I'll put the arrow in a bracket. Me doing this, I'm writing specifically for KC. But don't worry, your JAM is an optional exam, so you just have to understand basic concept. Guys, if you can hear me, let me know in the comment section. So you can see what we have done, because these are likely questions, and I'm going to solve more questions that pertain to this concept. Everybody pay attention. This reaction is not a standard reaction. It's just a reaction that is made up of letters. So basically, this is arrow. Are you not seeing arrow? So now, what number or what alphabet is standing in front of the arrow? It is M. The number. Listen, there is a law that guides all of these things, but just know how it works. So the number that is standing in front of the element should be raised as the power at all times. So what is the alphabet of the number? It is M. That is what I did. I raised it to the power of the arrow. So as soon as I'm done with one element, I'll go to the next, and it's S. For me to go to the next, I'll use times, which is dot. Dot means times. Are you there, maths now? So what do we do next? I will write S in a bracket as well, and raise it to what is standing, with it. And what is standing with it is N. So I'll raise it to the power N. Hope you are following me. So I am done with my product side. So basically, I will do the same for my reactant side. Are you there? Which is down. So I'm going to say over. Pay attention. What are my reactants? P and Q. So I'll start with P, put P in a bracket, and raise it to the power X because it's the X that is standing in front of it. And then I'm done with P, going over to the next, which is Q. I'm going to use times to separate them. So times Q in a bracket, and what is standing in front of it? It is R. It is Y. Are you there? So this is the answer to the question according to your JAMB past question. All these things are very easy. They are not difficult at all. So guys, if you are following me, let me know in the comment section. All right. If you are following, let me know in the comment section. If you are following, let me know in the comment section. If this is understood, let me know in the comment section. Very good. Take note of all these. They are essential. They are very, very essential, guys. Ensure you take note of all these. They are very, very essential. Take note of all these. They are very, very essential. Hope you are following. So let us solve as much we can in the course of this live class lesson. All right. We are going to solve as much we can in the course of this live class lesson. So ensure you are following. Ensure you are following, guys. Ensure you are following. All right. So that is for that. That is for that. That is for that. All right, guys. Let me know if you can hear me so we can proceed. Let me know if you can hear me so we can proceed. All right. Let me know if you can hear me so we can move further. Let me know. Do that quickly. If you can hear me, let me know in the comment section so we can move further. All right. Very good. Very good, guys. Very good. So let us proceed, guys. Let us move further now. All right. Let us move further. All right, so you can see we have been able to work on this question because I know they might just bring it like this in your exam, but I'm going to give you some real principles to follow whenever you are solving questions like this in your exam. It can just come out, not that it can, it will come out tomorrow in some person's exam. All right, so you all should relax so we can work on all these things. Relax so we can work on them step by step. So we can work on all of them step by step. So guys, you can see how it works. This one is not for standard reaction. They don't give us alphabet. Now, let me tell you something. In writing the equilibrium constant expressions for reaction, you need to understand some basic principles. Alright? You must take note of the state of matter of the substance involved. And that is what I'll quickly explain. And after explaining this, I'll quickly go to another aspect. We do little of biology, little of chemistry, like that. So that is for that. So I'll be wiping the board right now. So we can solve another question that looks like this. But this time around, I'm going to write for a proper reaction. So that's for you to remind yourself on how it works. Because all these things are not hard at all. Alright, they are not hard at all. So let us basically move into more standard reactions, alright, that you can see in your exam. Alright, so that is for that. That is for that. So guys, if you can hear me, let me know in the comment section. Alright, and also comment down when you'll be writing your exam. Comment down when is your exam date, when you're writing your exams. Alright, so let me know in the comments. So guys, do well to like the live. Alright, do well to like the live also. Alright, good. Very good. So let me quickly bring another question I know is essential here. Where is this one? See one question and let us tackle it together. All right, so one more. Let us proceed to another likely question on this aspect. Just note it. It can come out in your exam tomorrow. So now here's this one. It says this is a standard reaction, and it is a reaction between this guy, which is SO2 gas. All right, you can see SO2 gas. Most times the reaction will be balanced. They will balance it for you. SO2 gas reacting with oxygen gas. All right, and then with this reversibility sign, to know that this question is on chemical equilibrium, you are going to see this sign called the reversibility sign. Alright, so that is for that. So you can see the reaction. So let us basically go into what we need to solve in this question. All of the substance involved in this, what do you call it now? All of the substance involved in this reaction, they are, just pay attention, alright? Just pay attention. So let us trash it together. Alright, let us trash it together. Let us trash it together, everyone. So the question is still telling us to basically write the equilibrium constant expression. Alright, so let us do that together. Even before I solve, ensure you try it out yourself. Ensure you try it out yourself. Alright, ensure you try it out yourself. They are all easy. They are all very easy. You can do it. I've taught you all before many times. Alright, so that is for that. That is for that. Try it out yourself. Try it out yourself, guys. Ensure you provide the answer in the comment section. Alright? Alright, all of them are literally gases. Alright, so let us solve it together. Now, everybody pay attention. The question is still asking us to write the equilibrium. You know, I told us that, generally speaking, equilibrium constant expression could be either Kc, which is equilibrium constant expression written in terms of concentration, or Kp, equilibrium constant expression written in terms of partial pressure. But leave all of those things right now. Generally, your job will just ask you, write the equilibrium constant expression for this reaction. And from the previous question we solved, we already know that it is product over reactant. But now let me just tell us the real principle about all this. To write equilibrium constant expressions for reactions, we only take note, we only include species that are gases and aqueous in nature. I just said something very important. To write equilibrium constant expressions for reactions, we involve or we include substances that are gases or aqueous in nature. When you are aqueous, you will see the right AQ close to you. So that is what we include. But if you are a solid or a liquid, we don't include you in that expression. So check first. That's what you do. Because the first one, they just gave us alphabet, no state of matter. So all these guys, they are all gases, hence they'll be included in the expression. So what becomes the equilibrium constant expression for this reaction? My product, write it the way you are seeing. I just have one product and put it inside a bracket. Are you there? Don't go and write the number inside. The number of the alphabet standing in front of the substance should be raised as the power. So it's going to be raised as the power 2. And I have only one product. That is why I am done with my product side. Let's go back to the reactant. For the reactant, I have 2. Let me write for this. Will I basically put the 2 inside? I'll write 2SO2. No, you don't do that. You simply just write the guy, which is what? SO2. But the number standing in front of it should be raised as the power. And this is the number standing, it should be raised as the power times. Because I have another reactant, so you're going to times it. Times the other guy, which is what? O2. Are you there? Are you paying attention? And what is the power? What is the number standing in front of it? It is 1. So you can see it has been raised to the power. and this becomes the answer to the question. Alright, this is the equilibrium constant expression for this reaction. Guys, hope you guys are following me, alright? Hope you all are following. All these things are childish questions. They are so childish and you see them in your exam, alright? They are so very childish and you are going to see them in your exam. So that is for that. That is for that quickly. So let me give us one more question so we'll proceed. Remember I said that solids and liquids do not appear in this expression, but specifically like gases or aqueous solutions, they do appear in the expression. Hence, I'm going to give us another reaction. And the reaction is between carbon as a solid. Don't be aware that carbon is solid. And then reacting with oxygen gas with the reversibility sign to give me what? CO2. And you guys following me? And CO2 is a gas. Everybody listen and listen well. So what do we do in this case? We are still writing the equilibrium constant expression for this reaction. But first thing first, what we do, remember I said that observe all the states. If you are gases or aqueous, you'll be included in the expression. But if you are solid or liquid, you will not be. So first thing first, I saw a solid, which is carbon. I'm going to cancel it out. Are you there? So hence, what becomes the equilibrium constant expression? KQ, everybody. What now becomes it? Very easy. The concept is product over reactant. This reaction is balanced. Normally, when nothing is standing in front of you, we basically just write 1. Hope you all are following me. All these things are not hard. So you can see the number that we're going to raise it to the powers. They are not hard. Whenever a reaction, there's nothing standing in front of it, there is an invisible one. Alright, just pay attention. The product here is CO2. And then open bracket, close bracket, all raised to the power of what? 1, everyone. All divided by my reactant. And in this case, the only reactant that will be included is oxygen gas. So then, oxygen gas will be included, all raised to the power 1. And this is the final answer. Because told us that solids, things that are solid or liquids, they don't appear in the expression. All these things are very childish questions. So let us move further. You can see how well we've been able to trash this aspect. So without wasting time, let me just go to another area I know is very, very important. Let me quickly just go to another area I know is very, very important for you guys to note for your exams. So please and please note all these things. They are not hard at all. Note all these things. They are not hard at all. So let me just go into some vital areas that are very key for your exams. I want to quickly go into some vital areas that are very key for your exam. I just saw one now. I just saw one. Let me quickly trash it. I just saw one. So let us trash it together. All right? Let us trash that one together. Right away, guys. Right away. Right away. Please ensure you pay close attention to every single details that will be shared in this class. Because all these things are likely questions that you are going to see in your exam. Alright? So that is for that. That is for that. As we solve, we are going to solve some questions in chemistry. As soon as we have solved more questions, we simply do that. We simply do the same for biology. Alright? Like that. Alright? Until we have been able to trash a lot of aspects that are very essential for your exam. Alright, for those people writing tomorrow, which are the first set of students writing tomorrow, all these things, just calm down. You have read, so just relax. Don't be scared. Alright, don't be scared at all. Guys, ensure you like the live and also share with your friends. Like the live class and also share with your friends. Do that to your WhatsApp group and the rest. So this is another very likely question that you are going to see in your exam. Alright? So you can see first thing, I'm just trashing calculative aspect in chemistry. Before you know, we enter into theoretical aspect. So get ready. So this is 300 centimeter cube of an ideal gas. Class, this is a question that is inevitable to come out. Alright, it will come out in your exam for sure. It is inevitable. So basically just note it, alright? It says 350 centimeter cube of an ideal gas. The key word here is ideal gas, and they said exact. Alright, a pressure, everybody pay attention, of 1.05 atm. Alright, of 1.05 atm at 37 degrees Celsius. At 37 degrees Celsius, now the question now says, what amount, alright, what amount in mole, alright, what amount in mole of the gas is present? What amount in moles of this one is very childish because these are questions that you're going to be seeing tomorrow. So why not just relax and look at how they work? Whenever you see ideal gas And whenever you see they ask me what amount in mole, they might not put what amount. They will just say calculate the mole, calculate the number of moles. If you don't see amount in mole, they'll say what number in moles, or they will simply just say calculate number of moles. And you saw ideal gas. Just know that they want you to use your ideal gas equation that says PV, all right, is equal to nRT. So basically, it is what amount in mole, and you are aware that this mole is your small n. These things are not hard. So basically, make it subject. How do you make your n subject? You divide both sides of the equation by the things that are close to n, called the coefficient of n. And what are they? Arrow and t. Arrow and t. So what we do? Arrow t cancels arrow t. Remaining just n here is equal to what? PV over RT. Everybody, by this time you are supposed to know what P is. P is pressure, V is volume, T is not time but rather temperature, and R is what they call the molar gas constant. Alright, R is not rate constant. R is not rate constant, it is called molar gas constant. And for your level, there are about two constants to note. But I advise you to just know one. If you understand how to use one, you are good to go. And the one I want you guys to understand is this guy, which I believe you are supposed to know, which is 0.0821. Alright, 0.0821. All these things are very essential. Please note them. 0.0821. Alright, so basically, you can see how all these work. So this is arrow. Now, to use this arrow which you are seeing, there are criteria to follow. There are units to which your pressure and volume will be, because pressure and volume are in the formula. So to use this arrow which is 0.0821, your pressure should be in a particular unit, and the pressure should be in ATM, whether the volume in the question should be. These are likely questions. They usually come out in the JAM exam. So please note all these things. Your volume should be in DMQ. So go back to your question. Your volume here is not in DMQ, but rather CMQ. So quickly, you think, how do I convert my volume from CMQ to DMQ? Very easy. Remember this conversion factor you were taught in primary school, that 1,000 centimeter cube is equal to how many DMQ? 1 DMQ. Are you there? So what next do we do, everybody? What next do we do? We now come here and say, okay, the 350, you must ensure that you write that value underneath the guy you want that is up. 350 centimeter cube should not be under 1 ATM. It should be under 1,000 cm cube. It will not be equal to X DMQ. What we are looking for X. So X DMQ quickly will now be equal to what? Now 350, we are cross multiplying. So 350 centimeter cube times 1 DMQ, alright, all divided by 1,000 centimeter cube. Alright, so in summary, X DMQ, all these things are not hard, will be 0.35 DMQ. Hope you guys are following me. All these things are not hard at all, right? They are not hard. So that is for that, alright? That is for that. You can see what is happening, guys. You can see what is happening. So we can see we've divided 350 times 1, all divided by, 1,000. Alright, all divided by 1,000. And that's what? 0.35 PMQ. So what do we do next? Remember I said that your pressure should be in what? ATM. And the question, very, very straightforward. The pressure was in ATM. I have video lessons where that pressure sometimes will be in mmHg, millimeters of mercury. As a student, you need to know most times they will give you pressure in millimeters of mercury. In my detailed classes, my full lessons, I have like 8-hour plus lessons. I believe you have seen that lesson by now. 8 hours, 7 hours video detailed lesson that cut across all topics in chemistry. I saw questions like this. I think one of the questions, the pressure was in mmHg. Sometimes in your exam, they'll put the pressure in mmHg, and I said, for you to use this constant, your pressure should be in ATM. So you quickly convert that your mmHg pressure to ATM. And how do you do that? Very, very popular conversion factor that says 760 mmHg is equal to how many ATM? 1 ATM. So whatever mmHg that will be here, you will not put it underneath, will not be equal to X ATM. You make it subject, class is not hard. Please, I know that this thing is essential, so You don't know any other formula before, please note this formula that says PV is equal to nRT. Most times they will say calculate the N, which is number of poles, and it is PV over ROT class. Note it, please. You see tomorrow. For those writing from tomorrow, you are going to see question like this. It will not be exact values. It will not be. But this question pattern will definitely come out in some recent exam. Alright? So please and please note all these things. So you can see what we have established. So what becomes the number of moles? What's the pressure? We don't need to convert pressure because the pressure was already in ATM. That is ATM simply means atmosphere. So pressure, we've written it times our volume times the V. What is the volume? Is it 350 or 0.35? We simply use what now? 0.35 dm cube. Please we'll use the one of dm cube. All divided by, alright, all divided by what? What is there? Okay, first thing first, all divided by the arrow, and the arrow is what? 0.0821 times our temperature. Remember, in chemistry, your temperature must be converted to Kelvin from degrees Celsius. How do you do that? Kelvin temperature is equal to degrees Celsius plus 273. So Kelvin, what is the degree Celsius value? It is 37 degrees Celsius plus 273. And what is that? 37 plus 273. Quickly do that. 37 plus 273. That is about 310. Alright, 310 Kelvin. So basically here becomes 310. So tell me the answer in number of moles that you have solved. Do that in the comment section. What becomes the final answer, everyone? What becomes the final answer, everyone? What becomes the final answer? Do it to like the live, guys. Do it to like the live. Share with your friends. This is a revision class lesson. Class, what is the final answer? I'm not going to press the calculator. What is the final answer? All right. What is the final answer, guys? Are you sure? Somebody said 1.443. Please, others confirm. No, please confirm. That is not the answer. Confirm, all right? Do that, solve correctly. Don't rush, all right? That day in your exam, your calculator is not a scientific calculator. The calculator looks like this, something like this, right? This is how your calculator will be like tomorrow. So basically, solve your up first. You must take a pen. Solve the up first. And this one, 1.05 times 0.135. That is 0. Do it as if you're a baby, because don't go and rush it and you make mistake. You can see what we have done, right? So you now divide it down, which is what? 0.0821 times what? 310. That is 25, alright, 0.451. You can see what I've done, right? So you now divide, take your time. Take your pencil, don't take barrel there, pencil, so that you can clean when your book is filled. Do you understand? So that is for that. Everybody do that one for me. 0.3675 all divided by what? 25.451. That is the I've said the correct answer. Number of moles will now be equal to 0.01444 moles. Alright, based on approximation. Alright, class, you can see how it works. Please note all these things. They're essential. Note them, they're essential. This question, it will come out. I know what I'm talking about. It will come out. Alright? So guys, please note it. Ensure you like the live and share with your friends. Guys, I believe. So right now you don't know the formula or you are finding it difficult to remember the formula. How do you remember it? You say ideal gas and they'll say that's what they will ask. It is not same value, but basically this question will come out for sure. In your chemistry, it's going to be out. So guys, note it. So right now, note the formula. It is what now? PV is equal to nRT. And most times they'll say calculate N, which is PV over RT. So some N quickly for an ideal gas, what will you say? PV over RT. PV over RT. P is pressure, V is volume, R is thermomolar gas constant, and T is temperature, no time. You must ensure for me to, what is my constant for my arrow? My constant arrow is 0.0821. 0.0821. There are others like 8.314, and you have to know the right criteria to use that. That is why I don't want to stress you. Just note this one. To use 0.0821, ensure your pressure is in ATM. Most times in the jam, they'll give you pressure in mmHg. So that is why I gave you the conversion factor. Remember this, that 760 mmHg is equal to 1 ATM. So whatever mmHg they will be giving to you, convert to ATM by putting here X now. Guys, you know this simple mathematics. Alright? So that is for that. Alright? That is for that. I want to wipe the board right now. Right now, so I can solve another likely question. So you can see we have dealt with this aspect of chemistry. You can see we have dealt with this aspect. Let us leave here to do something. We're going to trash a lot of questions that are essential to be noted. So guys, please pay attention. Note all these things, they are very essential. Note them, they are very, very essential so we can move further. Guys, like the life and share with your friends. Ensure you like the life and share with your friends. Like the life nursing and share with your friends. So let's start with the next one, the next practice question right away. Alright, the next practice question right away. We are going to be solving a lot of questions. Alright, so that is for that. We are coming. We are coming. I want to quickly just go down in chemistry and bring questions under that aspect. Mixing down. Let us trash organics. All right. Let us trash organics quickly. Some areas in organics. Okay. I'm coming. Let me just do something right now. Let me just because I want to pick the areas that are high yield. Those high yield areas, they are very important. You cannot escape questions in organic chemistry. And the questions you're going to see, they are not questions that are tough. They are not questions that are tough. Alright? So guys, please note them, Note them. Some questions you're going to see naming. You definitely see questions that have to do with naming organic compound. You definitely see questions that have to do with isomerism. All these things are not hard. So first thing first, let us quickly solve some naming questions. Let us solve some IUPAC nomenclature questions, and then we'll leave IUPAC nomenclature to do something else. Alright? So guys, relax. We are coming, alright? Ensure you take your time. Just take it easy. All these things are not hard at all. They are easy. So I've seen one. Let us solve it together. Alright, the question on the board. So we'll trash it together. And it says, H bond C. We now have this bond CH3. Bond H. Bond C. Carbon bonded to another carbon. And there is a bond taking it up to CH3. Relax, alright? Don't be scared of all these things, they're not hard at all. I did have detailed lessons on IUPAC nomenclature, how to name organic compounds. So why stress? Just take it easy, relax. Alright? Because these questions, you see them for sure. They are inevitable. So carbon now bonding with chlorine up here. Another carbon. Now there is a double bond separating these two carbons. These two carbons rather. And this carbon is holding another chlorine up. And then bond C, H, and what? H, everyone. You can see what is happening. Let's check if all the representations are correct. Alright, all the bonds that are supposed to surround carbon. Carbon is these are questions they can ask you. Which of the following is true about carbon? Carbon is tetravalent in nature, and there is a reason why that is happening. What does it mean for carbon to be tetravalent? It simply means, by looking at all the organic compounds, it simply means that it is 4 carbons that is supposed to surround. It is 4 different substances that is supposed to surround carbon. So what do we do first of all? This is an IUPAC nomenclature question. So first step, identify the longest continuous carbon chain in this question. Alright, now pay attention. Everybody listen to me. This compound do you agree with me that it has a functional group? What are functional groups in chemistry? These are questions. Functional groups are basically atoms. They are bonds or radicals that determine the chemical identity of a compound. And it is that functional group that is the main site for chemical reactivity. All this is a big statement. Relax. I can see the functional group in this compound. And the functional group of this compound is this double bond. Functional group are things that are special. If you observe, there are single bonds that are connecting some of the carbons. Whether at this point you saw a double bond, hence this compound's name, this compound belongs to a family or an homologous series in chemistry. Homologous series, they are also called families of organic compounds. So this compound is an alkene. That is why naming this compound, the end of the name of this compound, the last name, we end with "in." Are you there? And the first rule in naming organic compound is to identify the longest continuous carbon chain. Alright? Look at all the carbon-carbon connection and look at the one that is the longest. First, let us quickly observe with our eyes the horizontal. Let us see if it's our longest. Relax. If it is our longest continuous carbon chain, let me observe. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. At the horizontal point, I had how many carbons? I had 5 carbons. Alright, so let me basically count again to see if I will have another longest continuous carbon chain. Everybody relax, alright? So let me count like this. 1, 2, 3, 4, 5. This one is still 5 carbons, alright? Let me count like this. 1, 2, 3, 4, 5. This one is also 5 carbon. But let me try and count like this. Wow. I counted like this. 1, 2, 3, 4, 5, 6. So you can see that when I counted from this side down, I had 6 carbons. So you can see that we've been able to identify the longest continuous carbon chain in this question. And what is the longest continuous carbon chain, everybody? The longest continuous carbon chain has how many carbons? It has 6 carbons. Hope you guys are following me. The longest continuous carbon chain has how many carbons? 6 carbons. So let us work it out together. This question is so easy. It is not difficult at all. Alright? So I can see my longest continuous carbon chain, and here is it. Alright? It has like 6 carbons. So I want to use this box to actually note it. You can see what we have done. See, listen, everyone. Pay attention. You can see what is happening here. Alright? So the longest continuous carbon chain right now is in this fashion. It is not just this horizontal. Because if I count horizontally, it is 5 carbon. If I count from this side, it is also 5. 1, 2, 3, 4, 5. If I count from this side, 1, 2, 3, 4, 5. So basically, I saw another carbon CH3 up. So I said, so since there is carbon there, that means we can form a longest continuous carbon chain. Look at the statement, continuous, longest continuous carbon chain. So basically, the longest is what? 6. 1, 2, 3, 4, 5, 6. So you can see that we've been able to identify the longest continuous carbon chain. Hence, the name of this compound we have, in organic chemistry, when a compound in its longest continuous carbon chain has 6 carbon, the name will be hex. Are you there? Hex. And we are already aware that this number name will end with in, we are coming. So next step, after identifying the longest continuous carbon chain, you basically number the chain. You number forward and also backward. So let's number first. 1, 2, 3, 4, 5, and 6. I've numbered forward. Let us number backward. That's the rule. Alright, so here is 1, here is what? 2, here is 3, here is 4, here is 5, and here is 6. You can see what we have done. The reason for this numbering is to ensure that our functional group, which is the baba of them all, which is what gives that compound its identity. And who gives this compound its identity? It is this double bond functional group, which signifies the alkenes. Are you aware that the alkenes are also regarded to be called the olefins? Note them, it's very essential. Note them, these things are very, very essential. So after we've been able to identify the longest continuous carbon chain and we've numbered it, we must ensure that we number forward and backward. So let us know the right numbering. The reason for numbering forward and backward is to ensure that our functional group has the lowest number as possible. Alright? So look at how it works. You must always ensure that your functional group, which is this double bond in this case, has the lowest number as possible. And now, how do you determine it? Look at it. When we number forward and number backward, check the numbers that are between the functional group. Alright? When you number forward, it was the functional group double bond was between carbon 4 and carbon 5. You can see what is happening. But when we number backward, it was between carbon 2 and carbon 3. So we'll go with the lower number. So when I've seen that alone, hence I'm going to remove this forward counting. So you can see that you don't always guess. You try to number forward and backward to know the best direction to count. That is why I count. The best one in this case is counting backward. Class, are you there? Relax. In this now, after numbering forward and backward, you then basically locate your functional group, and this is your functional group. Guys, listen. So now the numbers between the functional group, the two carbons between we have carbon 2 and carbon 3 between the functional group. You must ensure, I said that your functional group is only giving one number, alright? And you must ensure that you give it to the lower number. So between 2 and 3, who will it go to? It will go to carbon 2. So the functional group here is for carbon 2. That is why this compound name will now be hex 2 in. Now between letters and numbers there are dash. Between numbers and letters or letter and number, you basically use dash to separate it. But we are not done. Because basically, there are also branches. There are also substituents. You must give these substituents their correct numbers of position. Let us identify there is this substituent, there is this substituent, there is also this substituent as well. And also there is this, you can see substituents There are substances that are not hydrogen. Are you listening? You can see that I did not take hydrogen to be a substituent. Hydrogen is literally part. All these guys, they are called hydrocarbon. Alright? Elements made up of carbon and hydrogen. So things that are not hydrogen, they are substituent, and you have to give them numbers. Alright? You have to give them what, guys? Numbers. All these things are very essential. You must give this substituent what? Numbers. Very, very important. You must ensure that you give your substituent numbers. So that is how it works. That is how it works. So let us move further. Let us what? Move further, guys. So now, how do we do it? Now, at carbon 2 and carbon 3, we have chlorine. You know, in organic chemistry, listen, in chemistry, generally, Cl is chlorine. But in organic chemistry, their name will change from chlorine to chloro. So at carbon 2, carbon 2 is holding chlorine. So automatically it becomes 2-chloro. Carbon 3 is also holding chlorine. Automatically it becomes 3-chloro. Class, pay attention. Now, moving further, carbon 4 is holding 2 groups that are identical. This group in chemistry that is called the CH3 group, they call it the methyl functional group or the methyl functional group. Are you seeing it? Methyl. Anything that's CH3 is called methyl. So basically, at carbon 4, we have 2 of it. Carbon 4 is holding 2 of it. So that's why it's not the 4-4. Listen to me, it's not hard. Carbon 4 is holding 2 of it. So that's why it's 4-4. And di. The reason why it's di is because we have 2 of it. And it's not chloro rather, but methyl. 4-4 what? Dimethyl. Alright, dimethyl. You can see what's happening. Why? Because at carbon 4 we have 2 of it. That's why it's called 4-4 dimethyl. And between numbers and letters we use what? Dash to separate them. All these things are not hard. Practice makes perfect. Alright, just understand the principles. What are the principles, guys? What are the principles? The first rule in anything. You basically identify the longest continuous carbon chain. Observe the compound and just try to look which one is the longest, which one is the longest connection. And we saw that it was this guy that is the longest. After that, number that chain. Only the chain. After numbering, you number forward and backward. Alright, and ensure that your functional group you have identified rather. You don't worry, it's not hard. Alright, we'll solve more questions and then you see how it works. So I said that this thing is special because functional group are special groups. And alkenes generally they are called olefins. And alkenes generally they are sp2 hybridized. Class, these are jam questions. Alkenes generally they are what? sp2 what hybridized. So all these things we have basically formed, let us add it to the H2 So first, we must add all of these substituents alphabetically. And look at how it works. C and M, which one comes first? C and M, which one comes first? It is the C that comes first, alphabetically. So we'll go with the alphabetical order. We don't use the di. It's only the group name. Don't use di because yet we di, tri, tetra, or stuff like that. We compare only the name of the substituent. Chloro comes before methyl, so we'll go with chloro. So let's add it to the name. So we're going to add this one first. Class, listen to me. Now, you can see 2-chloro, 3-chloro. You can basically add them together because they are chloro-chloro groups. So then the name will be 2-3. You only added this one, 2-3. And now, listen, dichloro. The reason why it's dichloro because there are 2 of it. Alright, so let's add it to the name. So it's going to be 2-3. Alright, dichloro. Alright, 2-3 dichloro. Alright, 4-4 dimethyl X2N. That's the name of the compound. Alright, 2-3 dichloro, 4-4 dimethyl X2N. Guys, this is not hard. It is not hard. Practice makes perfect. Alright, let's look at the past question. Look at the answer. You can see here. Question number 51. You guys should look at it. Look at it. Alright. Look at it. Question 51. Option what? Let's look at the option. Option C is the answer. 2-3 dichloro, 4-4 dimethyl X2N. Option C. Are you seeing it? 51. Option C. 2-3 dichloro, 4-4 dimethyl X2N. You can see that all these things are really not hard. That is just practice that makes what perfect. It is just practice that makes what perfect. This is literally things you must note. They are very, very important. They are very, 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 very vital. They are very, very vital. Guys, relax. Take it easy. Alright? Just relax. So let us answer more questions. More questions are coming on this aspect. More questions are coming on this aspect of chemistry, which is organic chemistry. We'll be solving a lot of questions. So you guys should pay attention to all these details to be shared in the course of this live class lesson. Take note of all these details to be shared in the course of this live class lesson, so we can move further. Alright, so we can move further, everyone. Alright, so I'm coming to solve another one. Another likely question that I know that are essential. Another likely question that I know is essential for your exam. Alright, so I'll basically quickly go to some other aspect of organic chemistry. Alright, some other aspect of organic chemistry. So relax as we proceed. Relax as we move further. Because all these things are so essential for your exam. They are very, very important for your exams. Alright, so note them. Alright, I want to write the board so I can solve another one. So I can solve another question that is important for us to learn. Alright? Note all these things, they're important, guys. Alright, they are very essential for your exam. They are very, very essential for your exam. So right now, I want to bring some theoretical questions. Here. So you guys should get ready. I want to bring some theoretical questions here. Some theoretical question. Alright, and this one will not be on metals, no metals generally. Alright, metals, no metals generally. Metals, no metals generally. Metals, no metals generally. Listen, here is this one. It says, if a colorless gas, all these are high yield areas. They are questions that it came up in last year's JAM exam. So that's why I'm actually bringing out the questions here. So it says, if a colorless gas turns acidified KMNO4 from purple to colorless, what gas is most likely present? Everybody listen and listen well. Listen and listen well. Option A says CO2 gas. Option B says NH3 gas. Alright. Option C says H2 gas. And option D now says SO2 gas. Class, what is the answer to this cheap question on the board? What is the answer to this cheap question on the board? What is the answer to this cheap question on the board? I've told us many times without number that this question is on test for gases. Now they said, oh, this gas is colorless. And this gas, when it passes through a solution containing this compound, which is acidified KMNO4. You know, the name of this guy, listen to me, it's not hard. Quickly, this is KMNO4. They can simply ask you, what is the allopath name of this compound? Very easy. What is the full name of this compound? This is potassium. You know, a compound that has 3 elements, you name the first, you name the last. Alright, so if you guys can hear me now, let me know in the comment section. If you all can hear me now, let me know in the comment section. Do that quickly. Do that quickly. If you all can hear me, let me know in the comment section so we can move further. If you all can hear me, let me know in the comment section. If you all can hear me, let me know in the comment section. Do that quickly. If you all can hear me, let me know. Good one. So guys, do you understand how we got the +7? I was explaining the correct IUPAC name of this compound called acidified KMNO4. So basically, potassium is +1 plus manganese, which we're looking for. We name the first, name the last, before name the middle. It is manganese, but in this compound, it's going to be called manganate. Alright? So +1 plus X plus oxygen state, most compound is -2. -2 times 4 is if we always equate a compound's oxidation number to be 0. All these are rules. So that is for that. So we now evaluated +1, you know what is happening. Literally we ended at +7. But the key note here is that whenever a particular gas, which is SO2 gas, passes over this guy, which is acidified KMNO4, it changes. Let me know in the comment section if you guys can hear me. It changes the color of this compound from what? Purple to what? Colorless, guys. Alright? From purple to colorless. From purple to colorless. So moving further, there are other key points you have to know about other gases here, because the reason I brought this question is just to tell you guys key information how for you to be able to test for some other gases here that are vital. Like this hydrogen gas. Listen, how do you test for hydrogen gas? Very, very important to note. Alright, very, very important to note. Now, first thing first, you must know the flame to which hydrogen bonds. Hydrogen bonds with a pale blue flame. Alright, note it. They can ask you what is the flame to which this guy burns. It forms what? A pale blue what? Flame. And you have to know things about flame, alright, in chemistry. We have the candle flame, the Bunsen burner flame. Alright, you have to know the regions, the regions of all these flame. Some flame has 3 zones. Alright, all these things are essential, but I'll just be telling us some key points. Alright, so that is for that. So now moving further, guys, you can see I said that hydrogen bonds with a pale blue flame, and when hydrogen is burning, the key point is that it makes a pop sound as if you are making popcorn. You know how popcorn, when you're making popcorn, so it makes that sound, a pop sound when it's burning. Do you understand? So you basically take a test tube, for instance, and put a lighter splinter into that test tube. So basically, if the gas inside that test tube, you don't know the gas that is present in that test tube, and after lighting that little fire inside the test tube, and due to the pressure of the gas, it will now start burning more. Little flame or little fire you added into that test tube, you now see more flame. So when the flame is making a pop sound, you know that the gas in this test tube is what? Hydrogen what? Gas. All this is essential. Guys, note them. They are very, very essential, and you have to note them. They are very, very important. Alright, they are very, very important. Now moving further to another gas, which is ammonia gas here. Ammonia gas you are seeing. This ammonia gas has a characteristic pungent smell. Guys, note it. Ammonia gas has a characteristic pungent smell. Ammonia gas is basic in nature, meaning it's alkalinic. Yes, now this guy is a base. It's an alkaline base. Bases, to differentiate bases from acid. Acid turns blue litmus paper red. Listen to me. Acid turns blue litmus paper red. What about bases? Bases turns red litmus paper blue. Are you listening? So this ammonia gas have the ability to turn red litmus paper blue, alright, but acids generally turn what? Blue litmus paper red. Hope you are following me. Alright, I told you guys two things about ammonia now. It has a characteristic pungent smell, and basically it turns the color of what now? Moist red litmus paper blue, because it's basic in nature. But acids generally turn what? Blue. This A means acid, B here means bases. So acids turn what? Blue litmus paper what? Red, guys. Acid turns what? Blue litmus paper what? Red. Alright, so that is for that. That is for that. It is very, very important. So I want to basically move further to talk about something very, very important. Alright, I want to talk about something very, very important right now. And the gas here. Now, another thing you have to know about ammonia is that you can ask you, When ammonia reacts with HCl, which is an acid, listen, whenever ammonia reacts with concentrated, they are not big statements, just relax. When I'm giving you how to test for ammonia, do you understand? I told us first thing, it has a characteristic pungent smell. You can say, oh, when this thing is pungent, like it's pungent, the smell is pungent, you say, it could be ammonia, it could be other gases. Further confirmation to know that it's ammonia. Ammonia is basic in nature, so they will turn red litmus paper blue. And the final confirmatory test for ammonia is basically that when ammonia gas reacts with concentrated HCl gas, white fumes are produced. Guys, note it. Whenever this gas reacts with concentrated HCl, white fumes are produced. Very important. Alright, so you have to note them. Very, very important. So you have to note them. Alright, very, very important. So you have to note them. Guys, if you can hear me, let me know in the comment section because we are going to trash a lot of things in the course of this live lesson. Alright, so get ready, everyone. Get ready. Alright, so that is for that. That is for that. Another gas here that is important to talk about. Okay, I've talked about now SO2 gas. Not SO2 gas. SO2 gas has a burning matchy smell. This gas, are you aware that ammonia gas is produced by Haber process? Haber process. That's the process to produce ammonia, alright, which is NH3. Haber process. And the catalyst involved in Haber process to make ammonia be formed faster, they call it finely divided ion. Finely divided ion that you ground. Are you there? So that is for that. Alright? That is for that. That is for that. So that is for that. So let us move further, everyone. Let us move further to talk about other things that are essential here. Alright? And we said one of the tests for this compound is that it turns the color of what now? Acidified chemonophore from purple to colorless, and also it has the ability to the color of acidified K2CO207 from orange to green. See, listen, there's another form of compound, they call it K2CR207. Alright, this same gas you are seeing has the ability to change this color from orange. The initial color of this guy is orange, and when this gas passes through it, the color changes from orange to green. That is a test for SO2. You can see I've given us like 3 informations about SO2 gas. Alright, 3 informations about SO2 gas. First thing first, it turns the color of what now? Acidified KMNO4 from purple to colorless, and also this same gas, I know I'm stressing on this. This thing came out last day, it can come out in your exam as well. It can also turn the color of what now? Acidified K2CR207 from orange to what? Green, guys. From orange to green. These things are very important, alright? These things are very, very important. So guys, let us move further. Ensure you share the live lesson with your friends, alright? Ensure you share the live lesson with your friends. I'm just giving us key areas that are essential in your JAMB exam. Alright, key points I know that are very, very important in your JAMB exam. So guys, that is for that. So I'll be wiping the board so I can trash other areas that are key for your exam. So I can trash other areas I know that are essential that you are not going to escape questions from. It's not possible. You are not going to escape questions on these things we are talking about right now. So I want to wipe the board so I can quickly go into those areas. So at least I've trashed this one. Alright, things I know that are important, so let me leave here to do something else. So I want to leave here right now to solve more questions generally in chemistry that I know that are very, very important. Note the process to produce ammonia is called Haber process, and the catalyst involved is finely divided ion. Alright, so that is for that. That is for that, guys. Let us proceed. Let us move further. Alright, let us move further. We are going to work on biology very soon. Alright, just relax. Questions in biology will come out soon, and then we are going to solve them together. We are going to trash them together, everyone. Just take it easy. We are coming. Just take it easy. We are coming. Let me solve this one quickly, and then we can go into biology, answering biology questions. Alright? Alright, so another one, guys, that is very important, and it says calculate or determine. Calculate D. I know all these questions in my previous lessons I've stressed on them. I'm still stressing on them because I know they are high yield. Questions on them usually comes out like this, we are asking them. calculate the maximum. Calculate the maximum number. Calculate the maximum number of electrons. Calculate the maximum number of electrons in the M shell of an atom. In the M shell of an atom. Everybody, listen to me. This thing is very easy. In my 7-8 hours lesson on YouTube Live, I basically explained this question is on quantum number. Listen, everybody. Which quantum number describes shells? They call it the principal quantum number. Are you aware about that? That it is the principal quantum number in chemistry that describes the shells of atoms. I did not say principle. I said principal quantum number. And are you aware that it is signified or symbolized as N? And since I said describe shells, so the question would have asked myself, what are these shells? They include the K shell, the L shell, the M shell, the N shell, and the O shell, which are called the KLMNO shell. And these shells are giving numbers based on the N value. So these numbers are counted serially. N is 1. So listen, N for the K shell is 1. N for the L shell is 2. Like that, and like that. So they can ask you, what is the value of N for the K shell? 1. What is the value of N for the L shell? 2. What is the value for N for the M shell? 3. Like that. So the question wants us to get the maximum number of electrons that the M shell can occupy. And there is a formula to note. Whenever they ask you, determine the maximum number of electron in a shell. Because this one, I want us to get the maximum number of electrons in this shell called the M shell. A formula is used, and the formula is simply 2m squared. Class, notice. So for the M shell, listen, what is the N value for the M shell? It is 3. That's what we just said. We gonna say that N value gave rise to all of these things. So the N value for the M shell is 3. So for N for the M shell is 3. And the formula to get the maximum number of electrons in shells is 2m squared. So whenever we see N, we put our number 3. Are you there? All squared. Solve your bracket. So 3 squared meaning 3 times 3. That's 3 squared. That is 9. So here becomes 2 times your 9. That is what? 18. So altogether, in your option, you can look for 18. That is your answer. To determine the maximum number of electrons in shells, the answer is 18. Class, it is not hard at all. Alright? It is not hard at all. These things are childish. And these are questions that you'll be seeing tomorrow by God's grace. Alright? So you guys should relax and just take it step by step. Take it easy. Don't pressure yourself. Alright? You have read a lot of things. So why now? Why are you not scared? Alright? Take it easy. Don't worry. You'll be able to excel. Alright? So that is for that. Because I'm solving questions that are very, very important here. Questions I know that they are very high yield areas. Alright? So that is for that. That is for that, everyone. That is for that. I have more questions here, and let us look into them. Alright? Let us look into the questions. Let us look into all of these questions I have here, because they are very, very important. They are very, very vital and important, guys. So please, never you miss them. As I'm saying them right now, please take note of them. They are very, very important. Alright? Where are you? Okay, let me quickly say something here. I want to wipe the board so I can quickly say something. As a student, you are expected to know various organic families and their general formula or their functional groups. This is what I mean by what I'm saying right now. Everybody take it easy, relax. This one definitely will come out, alright? So let me quickly just write out some things that are important right now for you guys to know about organic chemistry. You are expected to know different families of organic compounds and their functional group or general formula. Alright? For their functional groups or general formula. And now we're going to start with the alcohols. Everybody take it easy. For the alcohols, what is their general formula representation? You know, they are represented with arrow bond OH. Class, listen very well. They can just ask you, which of the following represent the alcohol homologous series or the alcohol family in organic chemistry? It is arrow bond OH. This arrow here signifies what they call alkyl group. Arrow signifies what? Alkyl group. An alkyl group in chemistry is symbolized as CnH2n plus 1. So I can literally write this. Why I see arrow, pull that. So it's going to be CnH2n plus 1. And then bonding with my what? OH. The one of the functional group here, ever listen. What is the functional group in the alcohol family? It is this OH we are saying. That's the functional group. Which is your alkyl group? It is the arrow. Are you there? Which is also represented as what? This. So note the difference between a functional group and an alkyl group. A functional group are those special compounds, they are those special bonds or radicals or atoms that gives that compound its chemical identity, and it is the main site of reactivity. If, for instance, an alcohol is to react, when alcohols react with alkanoic acid, note this, are you aware that when alkanols, react with what? Alkanoic acid, what we form? We form these guys called the alkyl alkanoate, We form what we call the alkyl alkanoate, To form the reaction is so easy, and then water is formed, which is H2O. Are you aware that the alkyl alkanoate, we also regard them to be called esters? So when ester is formed in a reaction between an alcohol and an alkanoic acid, what reaction is that called? That reaction is called esterification. So you can see that this reaction is proceeding in two directions. It's going forward and going backward. The reaction that forms ester is the forward reaction. The one going forward is the one that forms the ester. While the one going backward is the one that forms the alcohol and the alkanoic acid back. And the backward reaction, they can ask you, which is the reverse reaction for esterification. The reverse reaction for esterification is called hydrolysis. Why is it called hydrolysis? Hydro has to do with water. So it is this water that is now splitting this guy. It is breaking it again to form what came together to form it. So water will split the ester or the alkyl alkanoate to form back our initial product or our initial reactant called what now? The alcohol and alkanoic acid. And that reaction is called what? Esterification. And the backward is simply called what now? Hydrolysis. The backward reaction is called what? Hydrolysis. The backward reaction is called what, everybody? Hydrolysis. So moving further, as a student, you're expected to know various homologous series and their general representation. There are others, alcohols are also regarded to be called alkanols. Alcohols are also called what? Alkanols. And there are others which include the alkanals. Are you aware that the alkanals are also called the aldehydes? The alkanals are also regarded to be called the aldehydes. And what's their own representation? Their own is arrow CHO. Arrow CHO. Remember I said that the arrow is just alkyl group, whereby the other guy will be a functional group. So the functional group here is the CHO functional group. And whenever I see CHO in organic chemistry, it simply means the alkanal. Structurally, it is drawn like this. Arrow bonding to carbon. And this carbon is bonding to oxygen with a double bond. And this same carbon is bonding to the hydrogen. So structurally, this is how this guy is written. Structurally, this is how arrow bond CHO is written. So in your exam, you might see things like they'll say, identify this family. What family will this guy belong to? Anything that has CHO, anything that has CHO on the arrow, it is an alkanal, also called what? An aldehyde. So, and that is for that. Any compound that has this C double bond O, that compound is a carbonyl compound. A carbonyl compound, or we simply say that compound has a carbonyl group. Because in chemistry, the C double bond O simply means carbonyl. Carbonyl. Hope you guys are following me. Hope you all are following me. Let me know in the comment section. So they can ask you which group of compound has the carbonyl group. But aldehyde have it. Because you can see from the structural formula, there is C double bond O. Whenever carbon is to bond with oxygen, it bonds with oxygen with a double bond. All these things are not hard. Other families of homologous series include the alkanones. And as a student, you should know that alkanones are also regarded to be called the ketones. Are you there? Alkanones are also called ketones, and their own is what? Arrow bond, CO arrow prime. This is how these guys are, which is the alkanones, also regarded to be called what? The ketones. Alkanones, also regarded to be called what? The ketones. Guys, all these things are essential. You have to note them. All these things are essential. You have to note them. Alright? All these things are essential. You have to note them for your exam. Alright? So, that is for that. That is for that. Alright? So, there are literally a lot of families and their organic representation or their general formulas. Alright? Like the likes of the alkanoic acids. For the alkanoic acids, they are also regarded to be called the carboxylic acids. Are you aware about that? The alkanoic acids are also regarded to be called the carboxylic acid, and their representation is arrow bond COOH. Alright? I can literally draw the representation, the structural form of them. But as a student, please note all these guys and their general formula. Alright? Note all these guys and their general representation. Just note them. Alright? They are important as well. So I'll be wiping the board so we can literally go to something else. Alright? But as a student here, maybe you have an exam on Friday, Saturday. Ensure you go watch my detailed lesson, 8-hour lesson on YouTube Live. Go and check it out. I solved a lot of, I basically taught a lot of topics in that 8 hours class lesson. I have like 2 of them. One is 8 hours, one is 7 hours. I have a full detailed organic chemistry class from the beginning till the end. I think that was about 7 hours as well. So go check them out on my YouTube Live. Alright, to have access and basically start learning for those who are still struggling and your exam is like a little bit far, like Friday, Saturday. Alright, you still have time compared to those writing tomorrow. Alright, so that is for that. So I'll be wiping the board so I can proceed. Alright, so that is for that, guys. Let us move further. So right now, I'll be moving into a very key area, which is pH calculations. Alright, this one is very, very important. There are some questions that are inevitable, and this one says determine the pH of HCl. Determine the pH of HCl given the open bracket H plus, which is the hydrogen ion concentration in mole per dm cube to be 1.00 times 10 raised to the power of minus 3. I know in the term exam there is no proper calculator that you are going to use to, solve these questions, but they are very, very easy to work out. Alright? So the question says calculate pH. So there is a formula for pH which says pH is equal to minus log, open bracket, close bracket, H plus. And this question is so straightforward, and that is how it is in the JAMB exam. They'll just say determine the pH which they say we want to do now, which we want to determine now, and the bracket H, so they gave it to us, which is the hydrogen ion concentration, and here is it. Alright, so let us impute. So pH will now be equal to what? Minus log, open bracket, close bracket, what's the H plus 1.00 times 10 raised to the power minus 3. Now listen everybody, this is how the question will come in your exam. They will not make it so complex that you cannot use, most times you students are scared of there is no calculator, how let's solve these pH questions. You should not be scared because the questions that you are going to see that day, they are questions that are easy for you. You can solve them without the use of a calculator. Now, let me tell you something. I already have detailed lessons on my channel, so you can literally just go to those lessons right now and go and learn how to solve pH calculation without the use of a calculator. But there are common questions like this that will come out in your exam whereby they will basically give you 1.00. Listen, whenever you have just the number, listen to me. The number is 1.00 times 10 raised to any power, be it minus 2, minus 3, minus 4, minus 5, minus 6. Just know that your pH answer will be the positive form of your power, and the answer is 3. Are you there? This only works whenever it is 1.00. This only works if it is what? 1.00. If it is 1.2, 1.3, it will not work. It's only now. Listen to me, everybody. So quickly solve this one. Calculate the pH of this solution. Alright, giving the H plus, alright, to be 1.00 times 10 power minus 6. Everyone, what becomes the pH? I told you guys, whenever your value looks like this, and these are common questions they do bring in the JAM exam, your answer, when it's 1.00, your answer is the positive form of your power, and the answer of the pH in this question becomes 6. You can see how it works, alright? You can see how it works. They are not hard at all. You can see how it works. They are not hard at all. But now, they can just make it further. They can say, okay, after calculating your pH, calculate pOH, convert your answer to pOH, very easy. That is why you must know this equation that relates pH and pOH, that says pH plus pOH is equal to what? 14. So what next you do, regarding pH to be 6 plus pOH, which we are looking for, is equal to 14. So pOH will now be equal to what? 14. This 6 comes here. It's going to be 14 minus 6, and what becomes the pOH? Alright, that's how it works. They can literally tell you to convert your answer to pOH, and that one is not hard at all. You know what to do it here. You know what to do it here. That's 14. Alright, 14 minus. Alright, 14 minus of 6. That is 8. So the pOH will now be what? 8 in this case. Class, are you there? Please take note of all these things. Though they can also bring values that are not just 1 point. They can give 1.5 times 10 to the power minus 3. This one now, you cannot tell me that the answer is 3. It's not correct because it's 1 point something. But cases whereby it will be correct is when it's 1.0. But I know how to solve it without using a calculator, but go and watch my lesson on YouTube on how it works. In my 8-hour plus lesson, I did it there. I have single videos that explain pH concept without the use of a calculator. Go and watch them there. In case they want to bring up, I basically know for sure that they don't make it hard. They don't make it easy by giving us values that are just 1 point something. 1.0 rather. Alright, so that is for that. Alright, so that is for that. That is for that, guys. Ensure you like, double tap on the screen and also share the live with your friends. So let us move further. Please note all these things. So for instance, I want to basically coin this question in another way. Everybody pay attention. Listen to me. I want to write the board. I want to write the board so I can rephrase this question so I can tell us what to do when you see questions like this in your exams. So you have to be very wise. You have to be very, very wise. You have to be very, very wise. Everybody listen. Now look at what we do. Listen to me. The question is straightforward here. It says, calculate the pH of HCl. Alright? Remember, the topic is not pH concept. And pH deals with acid. You don't know right from today. pH deals with what? Acid. Whereby pOH deals with what? Bases. And are you aware that according to that man called Svante Arrhenius, he said that acids are substances. When dissolved in water, they produce what? Hydrogen ion as the only positive ion. So when this guy dissolves in water, it produces what? Hydrogen ion as the only positive ion. Whereby bases, when they dissolve in water, they produce hydroxide ion as the only negative ion. So this will tell you that acids deals with H plus, whereby bases deals with OH minus. Are you listening? All these things are vital. So I want to rephrase this question. If you check now, look at HCl is an acid. As a student, you should know list of strong acids. You should be able to tell when an acid is strong and also when an acid is weak. When do we say an acid is strong? An acid is strong whereby all the content of the acid, the acid basically completely dissolves in water. That is when we say an acid is strong. Alright, so an acid is strong when the acid ionizes completely in a solution of water. Are you listening? But when we say an acid is weak when the acid partially ionizes, not completely now, partially ionizes in what? A solution or what? Water. Everyone listen to me. Now moving further. Listen everybody, listen. As a student, you have to know list of some common strong acids, and these are what questions, is on. These are what questions this week. Alright, these are what questions this week. So please note all of these things. Alright, note all of these things. Common examples of strong acids. Common examples of strong acids include your HCl, your H2SO4. All these are strong acids. Note them. Hydrochloric acid, the next hydrogen tetraoxosulfate 6 acid, even this other one, which is what? HClO4 is another strong acid. Alright? HClO4 is another strong acid. Even this one, which is called HNO3, is another strong acid. Alright? HNO3 is another what? Strong acid. All these things are very, very vital. Alright? All these things are very, very vital. Moving further, guys. Moving further. Listen. Are you aware that HNO3 is popularly the old name, they call it Aqua Fortis? Are you aware about that? That HNO3, the old name of the compound is called Aqua Fortis. And are you aware that whenever HCl combines with HNO3, alright, they form a mixture. They form a mixture called aqua regia. Are you there? Aqua regia. Please note all these things. Aqua regia. And the composition of these guys is 3:1. The composition of hydrochloric acid rather, combined with the HNO3, which is initially called aqua fortis, it is 3:1. Do you understand? And they form what? Aqua regia. Guys, note all these things. They are very, very important. Alright? They are very, very important. They are very, very important. When hydrochloric acid mixes with HNO3, they form aqua regia. The composition is 3:1. Alright? So you can see that hydrochloric acid is more than the HNO3 called the aqua fortis or nitric acid. Are you there? All these things are vital. And note all these. These are examples of strong acids to note in your exams. Alright? These are examples of strong acids to note in your exams. These are examples of strong acids to note in your exam. Alright? These are examples of strong acids to note in your exam. These are examples of strong acids to note in your exam. Alright, so that is for that. Class, if you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section. If you can hear me, very good. Very good, guys. Very, very good. So let us move further. Note those guys that they are strong acid. Examples of weak acid include H2CO3. This is a weak acid. Even this one called H3PO4 is a weak acid. And generally, organic acids are weak, like this CH3COOH. Alright, this is called ethanoic acid. Alright, anything that has COOH is an alkanoic acid because it has 2 carbons. And in organic compound or organic chemistry, a compound that have 2 carbons, the name will start with X. And due to the fact that we have COOH, that's why it's called ethanoic acid. Are you listening? The ethanoic acid, their own is arrow bond COOH. So this arrow is the alkyl called methyl. Alright, so the methyl is here, CH3 combining with this COOH. Hence, we have 2 carbons all together. That is why it's called ethanoic acid. And it's also a weak acid as well. Alright, it is also what? A weak acid. So that is for that. And please note all these things. Note their basicity. Like this HCl now, it is monobasic. These are common questions. HCl is a monobasic acid. Alright. What is basicity of an acid? It is the number of replaceable hydrogen ion present in one molecule of an acid. This is not the time to start basically explaining how it works. It's not hard. Note that HCl is monobasic. The basicity is 1. H2SO4 is dibasic. The basicity is 2. All these are common questions. You can just ask you, which of the following is the basicity of H2SO4? What's the answer? 2. Dibasic. Another common question is this one. They can ask you, what is the basicity of CH3COH? This guy is monobasic as well. Class note it. The basicity of this acid, which is CH3COH, is what now? Monobasic. Alright? Monobasic. So that is for that, guys. That is for that. Note all these points, they are essential. Note all these points, they are very, very essential. Note all these, they are very, very essential. So basically, that is for that. I want to basically talk about 2 terms called conjugate acids and conjugate bases. Alright, just relax. conjugate acids. Oh, I want to basically solve some questions on this aspect. I'm not done. Alright, these pH calculations. So now you guys will know how it works in your exam. They are not hard at all. Alright? They are not hard at all. Just relax, just take it easy. They are not hard at all. I'll wipe the board so we can move into other areas. Alright? So we can move into other areas. So we can move into other areas. I'm coming, guys. Alright, everyone listen well. Let me quickly just say something before I can conjugate acids and conjugate bases. Now, for instance, you asked a question in your exam on these pH calculations. They said, I'm not going to solve the question, I want to just tell us something. They said, calculate the pH of sodium hydroxide. Everybody pay attention. Remember I said that pH deals with acids. Alright? Remember I said that pH deals with what? Acids. Alright? Remember I said that pH deals with acid, but pH deals with bases. So, calculate the pH of this compound, which is a base. As a student, you're supposed to like sodium hydroxide is a base. Alright? Given the OH, which is the hydroxide ion, to be 1.00 times 10 raised to the power minus 9 rather. Alright? So everyone listen, you can see how this question was coined. Don't make mistake. Okay, let me just bring options. Option A, 9. Option B, let us say 6. Option C, 7. And option D, I'm coming guys, let me quickly do something. So I want to tell you guys something that is very, very important. I want to tell you guys something that is very, very important. No, don't rush, guys. Don't rush. Alright? Listen. The question says, calculate the pH of sodium hydroxide. Listen to me. What was the information given to you? They gave you an information for a base. Listen, is there any formula for pH that says pH is equal to minus log into bracket OH minus? Is there any formula like this? No, there is no formula like this. So, because pH always deals with what? Acid. pH always deals with what? Acid. Alright? So, the formula should have been pH is equal to minus log into bracket what? AH plus. But now, I'm aware they want to get pH. But the question is not straightforward. They gave us a value for base instead of a value for pH. So what do? We simply calculate for our base, which is pOH. Because it's pOH that has that minus log, that OH minus. Are you listening? So we simply calculate our pOH first. These are common questions that are so simple that for students want to fail, you don't have to fill this type of questions because they are giveaway questions. So pOH can be minus log into bracket. What is the OH minus in the question? 1.00. Alright, 1.00 times 10 to the power minus 9. So I told us automatically, when you are giving values like 1.00, the power will not be the answer, but positive form. Alright, sorry guys, pOH. Are you listening? But now question, because pOH that has OH minus, we can no longer relate pH and OH minus. It doesn't happen. So we now simply convert our pOH to pH. Like saying pH plus pOH is equal to 14. Alright, so pH will now be equal to what now? 14 minus pOH. Alright, pH will now be equal to what is 14? 14 minus what is pOH? 9. And what becomes the final answer? 5. So the answer becomes option D. You can see how it works. It is not hard at all. Alright, you can see how it works. It is not hard at all. If you can hear me, let me know in the comment section, guys. Alright, if you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section. If you can hear me, let me know in the comment section, guys. If you can hear me, let me know in the comment section. If you can hear me, let me know in the comment. You can see how it works. It's not hard at all. It is not hard at all. It is not hard at all. These are likely questions I know they'll bring tomorrow. You will come back here and thank me was bright for all these things because they will come out the way they are. Not exact same value, but the same concept is going to come out for sure. They've been doing it all over the years, and they're still going to do it again. Alright? So, for that aspect of calculating without the use of calculator, go and watch it on my channel. Alright, go and do that quickly. You can leave the live and just go there and watch it and come back to the live lesson. Alright? So, that is for that. So, class, I'm good with this aspect. For those other ones with 1.5, 1.2, 1.3, go and watch it. I have simple method to solve without the use of the calculator. Go and watch them there. So I want to wipe the board, everybody. I want to wipe the board, everyone. So I can simply go into that conjugate acid and bases. Alright, so you can understand properly how all of those things work. So you can understand properly how all of those things works. Alright, they are not hard at all. Alright, they are not hard at all. They are not hard at all. Conjugate acids and conjugate bases. First thing first, you have to know what they are before you can answer questions on them. So let's write them as a subheading. Conjugate. You've been hearing that, but people might not understand. Conjugate acids, alright? Stroke what? Conjugate bases. Who are these guys? Alright, so first thing first, I think we'll start with any of them. Alright, we'll start with any of them. Everybody listen to me. Listen and listen well, pay attention. Let us start with the explanation. Pay attention, let us start with the explanation. Pay attention, let us start with the explanation. Alright? Pay attention, let us start with the explanation. Everybody now, let's go. Listen to the first explanation. Everyone listen. When an acid donates a proton, I repeat what I just said. When an acids are different from conjugate acids. Don't take them to be the same, they are two different things. And bases are different from conjugate bases. So when an acid donates a proton, I just said something. When an acid donates a proton, I'm coming to explain what proton is, alright? When an acid donates a proton, the remaining species in that acid is what we call something, alright? It's what we call something, and it's simply called conjugate base. I repeat, relax. This proton we are talking about is hydrogen ion. Everybody listen. This proton, you don't know before, know it from today, because these are likely questions. This proton we are talking about, they call it hydrogen ion. And I said, when an acid donates a proton, when you donate something, because acids generally they are proton donor by these two men called Johannes Nicholas Bronsted and Thomas Lorry. Are you there? So basically what I'm trying to say here is this. When an acid donates a proton, so the acid is donating a proton, is giving out this proton. It has it too much. You know, acid contain H plus, now we've established that fact, right? So if they don't like it, go away, I have it too much. So what now remains in that acid? What will remain in that acid is what we call the conjugate base, and we will explain. Everybody relax. So I'm going to use this acid as a case study, which is HCl, hydrochloric acid. So let us donate our proton. For sure there is hydrogen. So for sure that hydrogen will turn to H plus, alright, which is the proton. What remains will still turn an ion. You know, we are splitting this acid. So that comes Cl minus. Normally it should be H plus 1. This proton should be H plus 1. You get what I'm saying? Alright? And it's Cl minus 1. Are you aware that whenever HCl you break it, you get H plus 1 plus Cl minus 1. Are you aware about that? So I'm trying to tell you now that whenever an acid donates a proton, this is the proton is donating. What is the species that remains? What is the species that remains? What is it called, everybody? It is called what? The conjugate base. So they can ask you, they can say from this reaction, which is the conjugate base? You will not be able to tell. Option A, they can just write hydrogen. Option B, they can write what now? H plus 1. Option C, they can literally just write anything. Alright? They can literally write anything. Alright, they can write with HCl, they can write option D, Cl minus 1, which is the conjugate base. Which is the conjugate base? Which is the conjugate base? Everybody, what's the answer? Option D. Are you listening? And how a conjugate base form? They are formed when acid donates proton. What remains is the conjugate base. And what remains is what? The conjugate base. Class, is it making sense? Let me know in the comment section. Class, is it making sense? Let me know in the comment section. Alright? Class, is it making sense? Let me know in the comment section. Class, is it making sense? Let me know in the comment section. Class, is it making sense? Let me know in the comment section. Alright? If what I'm saying is making sense to you, I repeat. Whenever acids donate proton, what remains is the conjugate base. Whenever acids donate proton, what remains is the conjugate base. All right, let me go to your past question and look at question on under acid, base, and salt. So we can bring a very common, similar question on this thing. So you see that they usually bring it in the exam. So please, you have to notice it. So I'm quickly going to the acid and base aspect of the past question, so we can quickly solve the questions on this aspect and what I just said, because they are very, very important, guys. They are very, very important. They are very, very important. Let me quickly arrive there and let us solve questions together. Let us solve questions together. All right. Whenever acid donate proton, acid, they like to donate proton. What remains is the conjugate what? What remains is the conjugate base. So I'm going to the aspect so I can bring questions on them so we can tackle them together. All right. So we can tackle them together. Where are you? Where are you? I'm coming, guys. I'm coming so we can do them together. So we can solve them together. Where are you? I think I've seen one. I think I've seen. Oh my god. Alright, hold on, guys. So we can trash them together. So you can see that, oh, these things usually comes out in the exam, and as a student, it's expected for you to learn them. Alright, it is expected for you to learn them as a student. Alright, it's expected for you to learn them. It's expected for you to learn them. Oh, I just saw. Oh my god, I just saw a question. Okay, class, let's solve this one together. Let us solve this one together. Okay, Evan, listen. Look at this question. It says this is HCl. This one is exactly the one we just solved. Is exactly the one we just solved. This one and here, I see another one that is different. So let us solve this one instead. Okay, let me do this. This is CH3 COOH. Alright, and I said it's reacting, don't be scared. It's reacting with OH minus, alright, which is the hydroxide ion concentration. Everybody relax, 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 relax. Alright? Relax and relax and relax. I'm coming. Okay, let us do this way. Alright, let us do this way. Let's follow the reaction. CH3, okay, this is H plus 1. And this is CH3 COO minus. Everybody, this is an acid, you are aware, called ethanoic acid. So in this case, it is donating a proton the way the HCl donated. So then I ask, what is the CH3 COO minus? They asked it in the past question. What is the CH3 CO minus, everybody? What is the CH3 CO minus, everybody? What is the CH3 CO minus in this question? What is it? What is it? Tell me, tell me. What is this? I told us whenever acids donate proton, the remaining species is called what? The remaining species is called what? Tell me in the comment section. Do that, do that, do that. Tell me in the comment section. Very good. Conjugate base. Alright? It is called what? A conjugate base. All these things are not difficult, everybody. They are not hard. Just understand things, understand principles, and you are good to go. And as a student, you don't know chemical equilibrium. Please go and learn it on my channel. I have a detailed lesson on that. Alright, you can quickly go learn it on chemical equilibrium. I have a very detailed lesson on chemical equilibrium. I'm just trying my best possible to just try and touch all areas I know that are essential. Try and touch all areas I know that are essential. So please and please, you can go to my channel and go and learn that thing. It's very, very important on chemical equilibrium. Alright, on chemical equilibrium. All these are essential. Alright, all these are essential. All of these are essential. So let us move further. Okay, another one. Another one now. All right, so I just saw a question now. Okay, guys, look at this question. It says, which of the following, okay, let me wipe the board so I can write this question out. It's important as well to note. It's on organic chemistry. Alright, it's in organic chemistry. So these things are not, I just take it easy. Learn electrolysis. Go and, as soon as you are done with this lesson, or we are done with the live lesson, go to my channel and go and quickly understand how you receive questions on electricity. You cannot miss it. Mostly the calculative aspect. So you're explaining right now, you don't know those basic formula, Faraday's first law, general calculations in electrolysis, Faraday's second law, and you are here. Go and watch that 8 hours lesson, alright, quickly. Just be skipping the area you know, just quickly, just be skipping some things you know, and then go to those areas that you don't know in the lesson. Alright, so let me quickly just solve this one I'm seeing here right now. Let me solve this one I'm seeing here right now. Alright, I'm gonna solve this one I am seeing here right now, everybody. So pay attention. It says, which of the following hydrocarbons, note this, hydrocarbons has the highest boiling point. Guys, this one is so cheap. You don't have to crack your head. Option A says methane. And methane chemical formula is what? CH4. Alright. Option B says ethane. And ethane chemical formula is C2H6. Option C says propane. And propane chemical formula is C3H8. And option D says butane. And butane chemical formula is C4H10. So get the answer to this question, just understand that the hydrocarbon with the longest carbon, the hydrocarbon that literally has the highest molecular mass or weight or molecular size, literally the hydrocarbons, because they are of the same family, the one that has the highest carbon, butane has 4 carbons, we have the what highest boiling point. So you can see how it works. You can see that boiling point increases among them based on how their molecular weight is, or their numbers of carbon chains are classically the same. The one that we have the highest boiling point will be based on the one that has the highest carbon. Alright, and butane here has the highest carbon. It's very, very easy, it's not hard at all. Alright, it's very, very easy, it's not hard at all. Alright, it's very, very easy, it's not hard at all. So that is for that. That is for that. Let us answer another one. Let us answer another one. Let us answer another question. All these questions are likely questions in your exam. Alright, they are likely questions in your exam. Alright, I'm trying to go to your first question. I saw a question here. They said the general formula for alkyl halide. Listen, this is alkyl. They said, what is the general formula for alkyl halide? In this life lesson, we have talked about alkyl. Halide in chemistry means the halogens, and they are represented as X. And this alkyl, I told us already, the representation is arrow, or we simply say CN H2N plus 1. So since it's alkyl halide, it will be CN H2N plus 1X. So the representation for an alkyl halide is CN H2N plus 1X. Class, are you there? It is CN H2N plus 1 what? X. This is the general representation for what now? The alkyl halide. This is the general representation for the alkyl halide. All these things are very, very important. They are very essential. Note them. They are very, very essential. They are very, very essential. You have to note them. Alright? You have to note them. Very, very important, guys. Very, very important. Alright? So that is for that. That is for that. So we can move further. Class, hope you all are following me. Alright? Hope you all are following me. All these things are very important. Okay, I want to basically do something here. I just saw a question. They said the general formula for the ethers. The general formula for the ethers, as a student, ethers they are homologous series. What is their general formula? I told us it is arrow bond. Okay, I told you guys when I taught organic chemistry, alright, in my previous lesson. But if you have forgotten, please note it. Ethers are represented as arrow bond O arrow. Please note it. Arrow O arrow, literally. Alright, these are the ethers. All right, ROR prime or just ROR. All right, ROR. Please note it. Letters they are like this. I'm just trying to pick all these questions so we can answer them together. I'm trying to pick all these questions so we can answer them together. All this is just know that you are going to see IUPAC nomenclature question like how to name organic compounds, how to name organic compounds. So please note it. How you can name organic compound, note it. It's very important. Note it, guys. So that is for that. So know that one. Because questions on that aspect will definitely come out your exam. As a student, you are supposed to familiarize yourself with what we call alloys. Alright? You are supposed to familiarize yourself with what we call alloys. It usually comes out in the JAM exam. They call them alloys. What are alloys? Alloys are metallic mixtures. Alright? Alloys are metallic mixtures. Note that. Alloys, they are metallic mixtures. So you are supposed to know that. Alloys are what? Metallic mixtures, and we have so many of them. Alright, we have so many of these alloys, and as a student, you have to know the common ones that usually comes out in the exam. Alright, the common ones that usually comes out in the exam for these alloys. So I'm going to start with these guys. Alright, alloys. They are metallic mixtures. They are made up of what? The metals combining together. When you combine metals together, alright. ROCO, for the press arrow that for ROCOO. These are the esters. Alright, these are the esters, or we can simply call them the alkyl-alkanoates. Alright, alkyl what? Alkanoate. Alright, for the alkanones, they are ROCO prime. Alright, we can just use the prime to separate them. You can see how it works. Are you there? Class, don't mistake, these are the alkanones. And alkanones also called what? Ketones. Alright, don't mistake it for those persons, in the comment section. Alright? Note all these things, they are very, very essential. So I don't know why the board to do something else. Since I know that are important, so I'm wiping the board right now. Know how to name them. Go and learn it on my channel on how to name organic compounds. I have detailed lessons on them. Alright? So after the live, you can quickly just go there and go and learn it quickly, alright, on how to name organic compounds. So let us quickly talk about some common alloys and their composition. Alright? Good. That's for Eta, for Francis or Conta. That's very good. That's Etas. Alright? So let us quickly go into alloys and their composition. The alloys is on the topic metals. Alright, alloys is on the topic metals. So let me just quickly talk about alloys and their composition because I know that they're essential to note. I know that they're very, very essential to note. Solubility, I've worked on that already. Alright, I've worked and checked on my YouTube channel. I have detailed lessons on solubility. So let us start with some alloys. Alright, the first one I want to talk about is what they call duralumin. This is an alloy. Alright, it is made up of various metals. Alright, duralumin, the base metal, the baba of them all is what? Aluminium. And the other guys involved is copper. Other guys involved is even this guy called manganese. Another one involved for forming this duralumin is magnesium. Alright, magnesium, copper, and also aluminium. So this one is the base metal. Alright, they can ask you which of the following elements are found in duralumin. Any of them are found, but the base metal is aluminium. The one that is more found is aluminium. Are you there? So magnesium, manganese, copper are all included. Now moving further, they can ask you what's the use of duralumin. It is used to make those body part of aircraft for construction of aircraft, because it is light. All right, it is what? Light and stronger than aluminium itself. All right, it is light and stronger than aluminium itself. It is light and stronger than what? Aluminium itself. So quickly, let's talk about ordinary steel. For questions on this can just come out. For ordinary steel, the composition is what? Iron and carbon. Are you listening? So steel, one of the base metal in steel, be it the kind of steel, is iron. Alright, is iron. Alright, note that. And this ordinary steel, they use it to make bridges, road construction for ordinary steel. We have other steels like stainless steel and the rest. Alright, we have other steels like the stainless steel. For stainless steel, listen. Alright, for the stainless, I have detailed lessons on all these on those my 8 hours lesson. Stainless steel is iron, chromium, nickel. Alright, iron, chromium, and nickel. That's for stainless steel. And stainless steel is used for making, cutleries and surgical instruments. All right. Stainless steel is used for making what? Cutleries and surgical what? Instruments. Note that. Whereby magnetic steel, some steels are magnetic in nature. For magnetic steel, it is made up of, iron. Iron is the first guy, and cobalt. Alright, this one is for making permanent magnet. Magnetic steel for making what? Permanent what? Magnet. Note that. Alright. Note that, guys. All this is essential to be noted. Alright. For there are some other common guys like brass and bronze. These ones are common examples. They are mixtures, metallic mixtures. Alright. What are the composition of these guys? The two major compositions is copper. One is made up of what? Zinc, and the other is made up of what? Tin, SAN. So brass is copper, zinc. Bronze is copper, tin. Brass is copper, zinc. Bronze is copper, tin. Other include alnico. Alnico is used for making permanent magnet as well. Alright, from the name, alnico. Aluminium, nickel, and cobalt. Alright, aluminium, nickel, this one came out last year. So notice, alnico is an alloy, and it is used for making what? Permanent magnet. Another include what they call permalloy. This one is nickel and iron. Alright, permalloy. Alright, this one is for making temporary magnet. It is nickel and iron that is the makeup. Alright, for making this one is for making permanent magnet, temporary magnet, and temporary magnet is also called electromagnet, which is caused as a result of what now? What we call is caused as a result of magnetization through electricity, literally. But you have to note here that for the permalloy, it is for making temporary magnet or electromagnet. Alright, temporary magnet or what? Electromagnet. There are other alloys, but these ones I know they are exam focused. Alright, they are what? Exam focused. Note them, they are very, very important. Note them, they are very, very important. So I want to quickly do something now. Alright, I want to quickly do something right now on a very, very important aspect in chemistry. Let me quickly write it on the board so I can talk about that thing right now. So I want to wipe the board. There are some questions that you're going to see tomorrow. So let me quickly wipe the board on alloys so we can work on them. This one is on this one right now is on redox reaction. Alright, this one right now is going to be on redox reaction. So pay attention. Redox reaction. How you can determine a particular value. Alright, just listen. Alright, they will give you, how am I going to do it now? They will give you something. Alright, let me write it here. It is, listen. Cr2O7 2 minus plus. Alright, Cr2O7 2 minus. Pay attention, everybody. Pay attention. Plus 14H plus. Yeah, plus 14H plus Xe minus. So give me Cr3 plus what? 7H2O. Alright? Pay attention, everyone. Pay attention. I'll tell you the questions that usually comes out on this aspect. Here is 2. Alright? They will not tell you, they will not ask you. They will say, what is X? Determine the value of X. What should be here? Option A could be 2. Option B could be 7. Option C could be 6. Option D could be 8. So let's work it out together. Let us determine what X could be. It's very easy. Now, this is redox reaction. It's a step in redox reaction. How do you solve questions on this aspect? We are looking for what X should be. What number should stand in front of the X. It is not guessing. It's about understanding. So relax and let's work it out together. First step is to bring out all the net charges in all of the substances involved. You don't need this one now. It's only all of the substances at the left and right outside. Bring all their net charge. What is the net charge of this guy? The overall charge, like the net charge holding everything, is minus 2. So you write it out. Are you there? What is the net charge here? Don't tell me it's plus 1. Normally here is plus 1. But don't tell me it's plus 1 because there's 14 standing in front of H plus. The 14, the number standing in front of it is always affecting it. Are you there? So basically 14 times that H, that plus 1 is going to give us what? Plus 14. Because are you paying attention? So what about that? It is 2 times the plus 3 and that is what? Plus 6. Are you there? Whereby the net charge here is 0. There is no charge at all. This is the first step to follow. Alright? This is the first step to follow. Alright? This is the first step to follow. These are common questions. You'll just be a reaction. You'll say, what is X? This x should be close to e minus, so we don't have to work it out. So first thing first, evaluate this guy. When you say minus 2 plus 14, that's what? Plus 12. Class, pay attention. What about this? Plus 6 plus 6. Are you there? So next thing you do, you not think. Because you want to balance charges. You doing this and you think of a number, you think, okay, you want to ensure that the charges you have in your left should equal your charge in your right. We are not saying that they should be 0, 0. We want the numbers to be the same. If it's 1 million charges here, there should also be 1 million too. Are you there? But so far, we are not done. We are basically evaluated, and so we saw that for this year, the net charge is plus 12. For this year, the charge is plus 6. So now it's not balanced. We want to make sure that what is at the left and the right, they are the same. So what do you do? Well, because now they want you to fix a number in this x. So what do you do as a student to ensure that? Listen, you want to fix a number for this x to ensure that, okay, when you now evaluate 12 minus or plus anything, will give you this plus 6. We want to ensure that they are literally the same on both sides. So I think because this electron is usually already in minus sign. So let's say if I put 6 for instance. Everybody listen. Let's say I put 6 for instance. So automatically this guy is already minus 6. Are you there? It's minus 6. Why? Because the 6 will times minus 1. That's minus 6. So when you evaluate, listen everybody. So here is minus 6. So when you now break it down further, what do you get everybody? What do you get? You are going to get what now? Plus 6. Are you there? Because 12 minus 6 is plus 6. So in summary, you can see that after balancing it, we've gotten the value that should be x. So after doing that, the charge in our left equals the charge in our right. So the answer will not be option C. It's not hard. I will give you guys your own practice question so you guys will see how it works. Alright, so you guys will see how it works. It's not hard at all. It's not hard at all. It's not hard at all. So you guys will see how it works. Alright? It's not hard at all. The 7 will not affect. We are taking the net charge. The net charge. There is only a 0 charge. Is it using plus or minus or? So it's the net we are taking. And when we did that was 0. When we did here 2 times plus 3 is plus 6. So when we did that it was plus 12. So nothing. Okay, what number should I put close to that x now? That will make me that, okay, when I evaluate these two guys, it's still going to give me a number that is exactly the same as my right hand side. And when I put 6, it gave me the number. Class, is it making sense? Class, is it making sense? Let me know in the comment section if all these things are making sense. Let me know in the so I can give you guys your own practice question. You can see that it's not hard, eh? It is not hard at all. Class, is it making sense? Let me know. It's a common question that they usually bring in the JAM exam. So please, you have to note it and other chemistry related exams. So you have to note it. Class, is it making sense to you? Is it making sense to you? Let me know. Is it making sense? Alright, how did I get minus 2? Where are you seeing minus 2? Look at it now. We are picking the net charges. There's an invisible one here. Alright, same applies. There's 14. So 14 times plus 1. That's plus 14. 1 times minus 2. That's minus 2. It's not hard. If you were here when we did it, it's not be a problem for you. So remain in the life. Don't leave. If you leave, it will be a problem. Alright? So that is for that. Class, is it making sense? Let me know in the comment section. Alright, is it making sense? Let me know. Very good, very good, very good. Guys, like the live. We have a lot of persons here. So do it to like the live. Alright? Do it to like the live. Like the live. Let's get to about 500 likes. Do that right now. Guys, ensure you like the video and share with your friends. Like the live and share with your friends. Because I want to give you guys your own practice question right now. I want to give you guys your own practice question right now. I'll take it one more time for those who just came. So basically, listen everybody. What we did, they gave us a reaction. Here was X. They said look for the X. That's what they want us to do. So I brought out, listen. I brought out the, don't distract yourself. I brought out the net charges. What is the total charge here? Minus 2. I brought it out. 1 times minus 2 minus 2. Are you there? So I brought it out. 14 times plus 1 plus 14. Are you there? So basically, this one is what we are looking for. So it remains like this. Just there. Leave this 6 that is coming down. If you were here, it will not be a problem. Eh? So basically, leave this one alone. Leave it alone. So here, what's the net charge? 2 times plus 3, that's plus 6. And that one does not have a charge, that's why it's 0. So evaluate this one first. Plus 14 plus minus 2, that's plus 12. Alright, and here is plus 6. So it's not balanced. I said, when you want to balance your charge, you must ensure, when you want to look for the X value, you must ensure that the charge on your left equal the charge on your right hand side. Class, this is not hard. They are not hard. Then you just take it easy. Take it easy. Are you there? Relax. So let us move further. Alright, so after that, I had to think of 6. When I put 6 here, it now gave me minus 6. Plus 12 minus 6, that's plus 6. And here is only plus 6. That's why the charges are balanced. Because your question is coming now, so we can solve your question, guys. Alright? Alright. So class, I want to basically just hold on a little bit. I'll be back in a few minutes so we can move further. I'll be back in a few minutes so we can move further. Alright? I'll be back in a few minutes so we can move further. Guys, if you can hear me, let me know in the comment section. If you all can hear me, let me know in the comment section. If you all can hear me, let me know in the comment section. If you all can hear me, let me know in the comment section so I can move on to give you guys your own practice question based on what we just did now. Are you all getting ready for your own? Hope you solve it correctly for me. Because this is what you are going to see tomorrow. So ensure you get it right. They are not hard at all. They are not hard at all. They are not hard at all. Remember, this concept has to do with ensuring that the charge you have in your right should equal the charge in your left. That's the sole aim of getting the correct value for x. Class, are you there? The charge in your right should equal the charge in your left hand side. That's the sole aim of balancing this x. For those who were with us, it's not hard. So I want to wipe the board. I want to wipe the board right now so I can give you guys one practice so that is similar to this one exactly. It will just come out like that in your exam tomorrow. And also understand how to calculate oxidation number. I have it on my channel. Go and find it and watch it. Oxidation number by right, and you are going to go on that aspect. It's very important to I know what I'm saying, though. But this one now, all of them are on the topic redox. This one is on redox reaction. It's a part of redox that they usually ask questions on. But due to the fact that I want to just explain this, you can know that this one is very, very important to note. It usually comes out, and when you know it, you will definitely get it. Alright? So another one right now, let us work it out together. This is SO2 plus water. Alright? SO2 plus water. Everybody pay attention. This is SO2 reacting with water. Reacting with H2O. Alright. So now give me what? Let me check. So give me SO4 2 minus plus 4H plus. So give me SO4 2 minus plus what? 4H plus 1 plus Xe minus. You can see where the Xe minus is in this reaction. Everybody don't be scared of where is it, Don't be scared of where the X is. All that matters, you understand what you are doing. I'm not done writing the reaction. Let me finish first before we solve it together. And here carries 2 based on the question. Alright, here carries 2, and let us work it out together, everyone. Let us work it out. For those who just came, ensure you listen. And let us work it out together. What is the sole aim here? We must ensure that the charge you have in the left should equal the charge in our right hand side. Everybody, let's work. What's the net charge here? I told us whenever you don't any plus or minus, and that guy does not have any charge in summary, the charge becomes 0. The net charge is 0. What about this water? You cannot use the number in front of it. I said take note of this guy. So it's when this guy when there's something here that the number will affect it. So there's nothing here, so automatically the net charge also for this guy will be 0. So in summary, everybody, what's the net charge in the left hand side? Class, can you guys hear me now? Let me know in the comments if you can hear me. Let me know in the comment section if you can hear me. Let me know in the comment section if you all can hear me. Let me know in the comments if you all can hear me. Alright? Very good, very good. So basically, look at what just happened. You know, here, plus 4 minus 2 is plus 2. So if I'm not put the minus 2 here, they will not say evaluate each other. Plus 2 minus 2 that we have put here for the x. So in summary, the x will now be equal to what now? 2. Do you understand, everybody? It's not hard. So that will be the answer. Class, do you know how it was solved? Class, is it clear to everyone? Is it clear? I'm going to take it one more time. So basically, what did I tell you guys? You bring out the net charge first. So here net charge is 0 because there's nothing here. There's no plus or minus here. It's 0. Same applies. There's no plus or minus here. That's why it's 0. So when you evaluate, you're still going to get 0. So whatever here the net charge is minus 2 because 1 times minus 2 is minus 2. That's here was minus 2. Alright? And here is plus 1. But 4 times plus 1, that's why it's plus 4. Initially, here was nothing. Here was x. Are you there? So we have to evaluate. Plus 1 minus 2, that's plus 2. So then, we not think of the number we said, we want to ensure that all the charge we have in the left and the right will be equal. Here, 0. So this right hand side should be 0. So what should we put in place of this x to make this other side to be the same as this side? So basically, you put in 2 here, automatically, your electron has a negative sign, so it can be 2 minus 2. So minus 2 minus that, minus 2 plus that 2, basically you are going to get 0. Class, is it clear? That's why 0, 0 balance. Class, is it okay? Let me know in the comment section if it's okay. Let me know in the comment section if the network is okay. Let me know in the comment section if the network, if it's okay and everything is okay. Alright, this is redox reaction. Class, let me know if everything is okay. Let me know if everything is okay. Just let me know if everything is okay. Let me know if everything is okay. It's not hard. Let me know if everything is okay. Alright, let me know if everything is okay. Literally, it's not hard then. Practice makes perfect. Practice makes perfect, guys. Just take it easy. Relax, relax. All these things are not hard. Alright? These are hard to come out in your exam. So just take it easy. I've solved the first one. This is the second example on this aspect. So it's not hard, Okay, I'm gonna give us one more. I have a detailed lesson on stoichiometry on my channel. Go and check it out. For you that ask stoichiometry, I have a detailed lesson on stoichiometry on my channel. Go check it out. Go check it out. Go check it out. Let me give us one more question on this axis. Let's see how it goes. I want to give us one more question on this aspect. Let us see how it goes. It's not hard. All right. This one is so that you guys can work it out yourself. This one is MnO4 minus. All right. So let me wipe the board so I can bring that one now. Where are you? Where are you? Where are you? Let me wipe the board. Yeah. Hold on. Hold on. One more question on this aspect. So let's see what we can do. It's literally easy, just about practice. Practice makes work perfect. Practice makes perfect, guys. So I'm gonna go and find the question. All right. Remember the charge on your left, trick or your charge on your right. That's the sum of all these things. So here is MnO4 minus, yes, MnO4 minus to give come, let me bring out the reaction properly. To give us Mn, it should be Mn. Okay, let me get it here. Hold on. I'm coming. I'm coming, guys. Okay, let me wipe this one so I can bring a fresh one. Alright, related to what I just did. So you guys can master it well. It's important, It's very important to note, please. Note it. Because you might see it in your exam for those writing tomorrow. Just relax, relax. I know, just take it easy. Let me solve this one first. Now, this one should work now. What's the problem? The network is crazy. I'm trying to find questions. Alright. Okay, no. Alright, think I'm good now. Okay, class, look at this one. Class, I was on track. MnO4 minus plus 8H plus Xe minus to give me Mn2 plus. Alright, class, what is the value of X for your electron? Plus water, 4H2O. So tell me guys, tell me quickly, what should be X? Class, what should be X? Tell me, very cheap. I've taught us many times. Literally, here like just minus means minus 1. So the net charge here is minus 1. What about here? Here is plus 8. Hope you are aware, right? So basically, we are looking for this guy. So what about here? Here is plus 2 and here is what? 0. Right? There's no charge here. So now, minus. Here, like so, doing evaluation, here is plus 7, right? And here altogether is plus 2. So what do you put here to ensure that this side and this side equal each other? I think this X will occupy something like, or it will occupy 5. If I ensure that it occupies 5, altogether here will be minus 5. Because this guy is carrying minus sign. 5 times minus 1. Alright, here is minus 1, so it's minus 5. So evaluate them together, that's plus 2. So basically at the left hand side we have plus 2, at the right hand side we also have plus 2. Class, is it making sense for us? Class, so the answer is what? 5. Don't tell me that the answer is plus 5. Just say that the answer is what? 5. Alright, the answer is 5. The x value is what? 5. A very common question. So note it. The x value is what? 5, guys. Alright, don't say it's plus, so just say 5, 5, 5, 5. Alright, that's the x value. Is what? 5. It's very easy. It's not hard at all. It is not hard at all. It is not hard at all. So know what you are doing. Know what you are doing, guys. They're essential. Note what you are doing. They are very, very important. Let me give us straightforward reactions. Said, sir, please, can you make the video available later? I'm still watching that 8 hours on. Okay, no problem. The video will be available as soon as we are done, all right? So you just relax, peace, just take your time and watch it, and watch the 8-hour lesson, and then when you're done, you can come back here and rewatch this revision class. So let me give us one more that I know that there is essential. So I believe we are good on this aspect. So another one that is similar, all right? That one, this one's even more simpler. They are even more simpler, guys. They are even more simpler. So let us work them together. Alright, let us walk them together. Let us walk them together. And look at this one. Everybody relax. Look at it. Look at it. It says 2I minus. So you know this minus 1. So give me I2 plus x e minus 1. What is the value of x? So cheap, like A, B, C, D. So easy. Like, guys, work it out, work it out, work it out. What up? So what becomes the answer? Remember, I told you guys that you must be very careful, identify all the charges first. Alright? Work it out for me, work it out for me. So easy. Alright? So the net charge here is minus what? 2, right? Yes, now 2 times minus 1 minus 2. What about here is 0. Yes, now what about here is what we're looking for. So as a student now, here is minus 2, they're not equal. So what will you put here to ensure that here becomes still minus 2? That'll be the question you think of, right? Yes, now. What do you put there to ensure that here is what? Minus 2. That's what you think of. Class, are you there? Alright, what do you put there to ensure that here is what? Minus 2. That's what you think of. I think I have to put 2 here. Because if I put 2 here, automatically, for my x now, if x becomes 2, here will now become what? Minus 2. Are you there? So, when you evaluate, here still become minus 2, and minus 2, here becomes what? Minus 2. You can see that they are equal charge. Class is not hard. Alright, so basically, the x value here should be what? 2. So we'll go and look for the option that has 2, that's the answer. Alright, look for the option that has 2, that is what your answer. Look for the option that has 2, that is your answer. Class, is it making sense for us all? Class, is it making sense for us? Let me refill this, Macab. Class, is it making sense to us so we can move further? Are all this making sense to us? Very good. Please note this thing, it's important. It is very, very important. So I can leave here now. So that is for that. Right now, let us quickly just revise biology a little. Alright, go and watch my channel, Electrolysis, as a preferential teacher, oxidizing reducing agent. I have detailed lesson on all these things. So it is time for biology. Alright, then let us play with biology. Let us play with biology right now. So I'll be writing the question as I read the questions, we analyze them together with their options. So you guys should get ready for biology. Alright, so question number 1. Question number 1 right now for the biology class lesson. Alright, question number 1. For chemistry, if you are not offering biology, you can quickly go to my video lesson on my 8-hour lesson for the engineering student. Alright, for the engineering student, go to my channel to go and watch the 8-hour lesson for those not offering biology. Alright, so for those offering, remain here so we can start. I'm going to pass the past question I have. So let us start tackling questions in biology generally from the beginning. Alright, from the beginning of biology. Alright, so that is for that. Now look at this question. This question is on nutrition, still on and also on a basic classification of living organisms. This is Euglena, right? Euglena is an autotroph. Euglena is an autotroph, or Euglena is an autotrophic organism. Let's use the word according to the past question. Is an autotrophic organism because why is Euglena autotrophic? Alright, because Option A has flagella. Is that correct? Is it because it moves to the end of flagella? That is why it's autotrophic. Because it has a plant, question, another option has plant and animal features. Alright. Option C is found in water. Is it why it's autotrophic? Think well though. Option D, it is listen, option D can manufacture its food. Class, what is the answer? Before I solve, try to tackle it yourself. Before I solve, ensure you tackle it yourself. Before I solve, ensure you tackle the question yourself. It is very, very easy. Before I solve, ensure you tackle the question. Alright? Alright? So, this question is so easy. The answer is what? The answer is D. Alright? Whenever you see that an organism is autotrophic, Euglena is basically, an autotrophic, Euglena is, how am I going to say it now? Euglena is what? A protista. Alright? On basic classification. We have kingdoms of classification which include the kingdom monerans, protista, fungals, plants, and animals. Are you there? And Euglena is that protista that has both plant and animal-like features. Alright? One of the, you can say I said it has plant and animal-like features. So Euglena has like two properties or two nature. Sometimes they behave like plants, and other times they behave like what? Animals. Are you there? And one of the plant-like feature in Euglena is because it has what we call chloroplast. When an organism possesses chloroplast, most times we say that organism is what? A plant. Yes, it's only plants that have chloroplast. But this time around, Euglena that is an animal also has chloroplast. So Euglena is what? It has both plant and animal feature. And when you have chloroplast, there is a pigment inside chloroplast. And what is that pigment called? They call it the chlorophyll pigment. And this is what is essential for an organism to be able to produce their own food. And this is seen in plants only. Are you listening? But Euglena that is an animal also has this. And when you have this, you can produce your own food. And when you can produce your own food, you are an autotrophic organism. Because heterotrophic organisms are organisms that cannot produce their own food. They depend on already made food. Alright, like we humans, we are heterotrophic in nature. We are what? Heterotrophs. Alright, we are what? Heterotrophs. So basically, the answer to this question will be option D. But before I move further, I have to analyze this question properly to tell us key things about Euglena. Alright, to tell us key things about what? Euglena. Very, very important. Very, very important, guys. Very, very important. Alright, so let us move further on talking about this Euglena stress. Let's stress on Euglena. So Euglena, basically, we are aware that Euglena, based on the cellular level, is unicellular in nature. It's a simple organism. Euglena is unicellular in nature. That means they are made up of just one kind of cells. Are you listening? Euglena, and also not just unicellular, they are eukaryotic in nature. Alright, they are eukaryotic, meaning they have a well-defined nucleus. Eukaryotic was in nature. They are not prokaryotic. When you are prokaryotic, most times you'll be a moneran. Alright, because monerans are prokaryotic, like the bacterials and the blue-green algae. Are you there? Bacterial blue-green algae, they are prokaryotic in nature, meaning that they don't have a well-defined nucleus. Alright, every cell that is eukaryotic should have three components. Alright, should have this membrane, alright, that controls things that enters or leaves the cell. Alright, and this membrane, they call it the cell membrane. Are you aware about that? This membrane, what's it called? Cell membrane. And if you don't call it cell membrane, you can call it what? Plasma membrane. Or if you don't call it plasma membrane, you can call it the plasma lemma. Are you listening? So all cells that are eukaryotic, I'm not talking about bacterial cells or the blue-green algae cells. I'm talking about eukaryotic cells. Like all the cells in our body, they are eukaryotic. Like Euglena now is eukaryotic. Like amoeba, they are eukaryotic. All other organisms, plants, that are eukaryotic. Alright? So basically, you should have a cell membrane. Not just that, you should have a well-defined nucleus. And this is the nucleus. And the dense part of the nucleus, they call it the nucleolus. Alright? The nucleolus. Are you there? This one is the nucleus. The dense part is called the nucleolus. And this empty space that is jelly-like is called the cytoplasm. So all cells should basically contain this three parts. If you are a eukaryotic cell, you should contain these three components, which include the cell membrane, what serves as a gate that controls substances that enter or leave the cell, and also the nucleus, which basically has the nucleolus, and also that part where complex reaction occurs, because this is where all of those small organelles, those small organs are found, called organelles. Are you there? And this is where the reaction occurs. This is where the metabolic processes is not hard. Metabolic means this is where the reaction in the cell occurs, be it osmoregulation, excretion, nutrition, stuff like that. So you should understand this about a cell. All right, you should understand this about what a cell, guys. All these things are very, very important. So one of the plant-like feature of Euglena, as a student, you should know that Euglena, they contain chloroplast. That's my first explanation. All right. And when you have chloroplast, you will be autotrophic in nature. All right. When you have chloroplast, you basically be what autotrophic in nature. Are you there? Another, okay, we said that already. The plant-like feature is that they have chloroplast. All right. And let us quickly just talk about the animal-like feature. One of the animal-like feature is that Euglena don't have a cell wall. A cell membrane Euglena has, are you there? Does not have a cell wall. You know, despite plants generally have cell wall. That accounts for their rigid nature. But Euglena, that's why Euglena is not totally a plant. Euglena is a plant and animal. They don't have cell wall. Alright. Instead, they have cell membrane. Alright. Because it is animal cells that do have what? Cell membrane. Are you there? So listen and listen well. Alright. But for Euglena, that outer layer that covers Euglena, that outer layer that serves as the cell membrane, we call it pellicle. Alright. Pellicle. Alright, listen and listen well. Alright, it is called what? That outer layer or the outer membrane that covers the body of a Euglena is called what? A pellicle. Alright, it's called what? A pellicle. And other features where Euglena is an animal, you know, animals they move, while plants they don't move, but they can also move their body parts, you get. So one of the features whereby Euglena is an animal is that it moves with the aid of flagella. If they ask you what is the locomotive organ for Euglena, you simply say what? Flagella. It is not cilia. Who moves to the aid of cilia? It is paramecium. Paramecium. Are you there? It is not pseudopodia, also called phosphate. Who moves to the aid of pseudopodia? It's called amoeba proteus. Alright? So that is for that. That is for that. Now, okay. Now listen and listen well. Listen and listen well. Another feature of Euglena is that they store their food as what we call paramylon granule. Euglena stores their food as what? As what we call paramylon granules. Paramylon granules. Alright, note, take note of these things, they will help you a lot. Alright, take note of all these, they will help you a lot. Take note of all these, they will help you a lot. Alright, they will help you a lot, guys. So that is for that. Their food is stored in the form of what we call paramylon granules. Alright, so take note of that. I already have a detailed lesson on roots and tissues, plant tissues. Go check it out on my channel. Alright, so that is for that. You that asked that. So these are like the main features of Euglena, be it a plant, an animal, or be it behave like a plant or an animal. Alright, so that is for that. I'm coming. Let me go and look for more questions I have here. I just said something about Euglena. Look at this one. It's on level of organization also. Let me wipe the board. Listen and listen well. Let me wipe the board quickly. It's still on Euglena. The question is still on Euglena. Alright. I just said that Euglena, they store their food as what? Paramylon granule. And this question just asks about that. Alright. This question on the board just asks, okay, which of the following features of Euglena is only found in animals? Alright. Okay, wait, let me see. Okay. I'm coming, guys. Alright, I'm coming. Let me go get one more question here. Let me just leave this aspect. They said, look at this one, everybody. It says, the rod in the retina of the eyes, what are they called? What level of organization are they? Are they cells? Are they tissues? Are they organ or systems? Now listen to me. In our eyes, we have what we call photoreceptors that are sensitive to light. Are you listening? They are called photoreceptors or cells of the eyes, called the rod cells and the cone cells. You can see the end of the word. Because the question says, the rod in the retina of the eyes are examples of what? The answer is cells. They are cells. They are not tissues or organs or systems. They are what? Cells. Are you listening? They are what? Cells. The rod, they are sensitive to what now? not too bright light, whereby the cone are sensitive to what now? Bright light. You get what I'm saying? Like black for the what do you call it now? For the rod cells, there are specialized cells that detect black and also white eye vision in summary. All right, but the cone, they are very sensitive to what now? Very bright light. You get what I'm saying? But in summary, rod cones, they are cells. Rod cones are what cells? Rod cone are cells of the eyes, of the what eyes. So note that, they're very, very important. Note that, they're very, very important. All right. Raw, they are sensitive to like dim light. What about cone? They are sensitive to very bright light. That's the difference between these two guys. All right. That's the difference between these two guys. That's the difference between these what two guys just mentioned. They are very, very important. All right. They're very, very important. Okay. Let us move further as to more areas that must be noted. To more areas that must be noted. Hold on, guys. So let us move further. Hold on. Let me go and find the question so we can proceed. Go and watch my channel. You that asked that about the circulatory system. I already have a detailed lesson. All right, go and watch them on my channel. They are very important. All right. So let us answer this question right now. It says, this one is on ecology because you know a state question on this aspect. It says, which of the following group of factors, which of the following group of factors is completely abiotic in nature? What does abiotic mean? All right, abiotic simply means those factors that does not have life in them. You understand? Whether biotic factors are those ones, or biotic components of the ecosystem are those ones that have life in them. So literally, when you see abiotic, simply means that it doesn't have life in them. You get what I'm saying? So, but they support the biotic factor in the ecosystem, or they support the biotic component in the ecosystem. All right. So that is for organisms to be able to live and survive. So basically, which of the following group of factors is completely abiotic? So let me read out the options. So guys, listen. Option A here says, listen. Option A here says salinity, light intensity, or just light, and also bacteria. Option B says temperature, pH, and soil insects. All right. Option B says wind, pH, and also light. Option D says fence, pH, and rainfall. Class, which one is the answer? Which one is completely abiotic? When you're abiotic, you don't have life in them. You don't have life in like there's no life. And you know what that means, right? All these things that have life, you know who are they? Who those guys are. Like option A now says salinity, which is salt content, right? Or salt level. Light doesn't have life. You understand? It just supports, the ecosystem, support those biotic factors. You understand? I'm not teaching the topic, I'm just trying to evaluate on things. Bacterial is a biotic component because it is what? It has life in it, or it has life. You get what I'm saying? Temperature is completely abiotic. Are you there? pH is completely abiotic. But soil insect, all right, is basically biotic, because this one is an organism, that's life. All right. Option C now. Option C says wind, which is basically, you know, what is to measure wind speed? It is what they call what? Anemometer. But what is to measure wind direction? Wind vane. Not all of those things. This pH level, all right, and this is light. So this one is one that's completely what abiotic. Option C. Fen, no. Fen is not. Fen is a pteridophyte, it's an organism. Are you there? So basically, D is not the answer because all those ones there's a biotic component here, there, and the one that is completely abiotic is option C. Class, hope you are following me. All right. Hope you are following me. Hope you are following me. So we can answer another question. Hope you are following me so we can answer another question. Note that all these things are important. All these things are very, very important. All these things are very, very important. So let's answer this question here. All right, the answer is C. What is the answer, guys? The answer is option C. Class, what is the answer? What is the answer? What is the answer? Quickly answer so we can move further. What is the answer to this question? What is the answer? Very good. So I want to people to solve another one that's similar to this. To solve another one that's similar to what this one. Alright? All these questions are what you're going to see in your exam. So take note of them. They are very, very important. Take note of them. They are essential. Take note of them. They are very, very essential so we can move further. Alright? They are very, very essential. Remember, when you're biotic, there is no life. When you're abiotic, there is no life. When you're biotic, you have life. You understand? Which are, you know, the biotic components include those of our producers, consumers, and the rest of the ecosystem. You understand? Those things that have life in them. Alright? So that is for that. So look at this. In a savanna ecosystem. What is an ecosystem? An ecosystem is a self-supporting system that connects the biotic and abiotic components together. It supports, it's a system that supports each other. The biotic component and the abiotic component of the system, they support each other. Do you understand? So in a savanna ecosystem, the abiotic factors, all these are jam pass questions, are, what are the abiotic factors? You know what they are. Option A, here is legume. This one is an organism, don't miss it. Here is comma, temperature, alright? And soil. They did not say soil insecto, so you have to be wise. Option B says water. You know, water doesn't have life. You understand? It's abiotic. It supports the biotic. It supports all three. You cannot survive without water for a long time. So water, temperature, you know, and soil. Alright. Option C says mineral. Okay, they said okay, I know. Let us proceed. Mineral, oxygen, alright, and reptiles. Alright, and reptiles. You understand? And option T says water, soil, and grasses. Class, what is the answer to this simple question as well? What is the answer to this simple question? Tell me. Very good. The one that is completely abiotic is what? Water, temperature, and soil. This one, there is an organism here like reptiles. All those are snake, crocodile, you get. These are grasses. They are plants. Do you get what I'm saying? And option A, these are legumes as well. They are also plants. So when you just say anyone that is a plant, those ones are biotic. Alright, so that supports the question. So we go with the one that is what? Completely abiotic, which is option B. Water, temperature, soil. Water, temperature, what? Soil. Alright. Now they can ask you which factor talks about soil. Alright, they call it the edaphic factor. Alright, edaphic factor. Talk about soil texture and everything. Alright, take note. Edaphic factor of the ecosystem. This factor basically describes, you know, anything that has to do with soil. Alright, including the soil texture, soil pH, you know, anything soil moisture, soil minerals, soil temperature, anything that is soil is edaphic factor. Alright, edaphic factor. So that is for that. Alright, that is for that. So let us move further. Everyone. So the question we ask ourselves, what is a savanna as a student? A savanna is a type of ecosystem, all right, or that is, you know, made up of tall and grasses with trees. Like any savanna has to be a place where you have many grasses with many scarce trees, but grasses are more than trees. All those trees, that's savanna, all right. Grasses are more in a savanna than, you know, with trees. Trees are just scattered apart, all right. Trees are just scattered apart. So that is for that. That is for that. So let us solve other questions here. Let us solve other question. There's a question here that says, it says, which of the following instruments is used to determine turbidity of water? Which of the following instruments that is used to determine turbidity of water? Turbidity of water. First of all, as a student, you have to know what turbidity is. You have to know what turbidity is. Turbidity of water has to be cloudiness of water. The cloudiness of water, or yes, the cloudiness of water due to what they call suspended particles. So to determine how cloudy water is, they use a very simple instrument called Secchi Dix. Please note it for your exam. The answer is Secchi Dix. Alright? The instrument used to determine, alright, Secchi Dix is the answer. Alright? To determine, the turbidity of water. And I told us turbidity has to do with what now? How cloudy water is due to suspended particle. Alright, and an option here says thermometer, that's temperature. Another one here says rain gauge, that's rainfall. The instrument used to measure rainfall is rain gauge. Are you there? The instrument used to measure rainfall is what? Rain gauge. Alright, note that everybody. Note that. All these things are important. All these things are very, very important. Alright, all these things are very, very important. Alright, so for another one here, they say hygrometer. That one is for relative humidity or humidity. Alright. Humidity has to do with the amount of water in air. Alright. Amount of water vapor in air. So for hygrometer is relative humidity or humidity, which has to do with the amount of water vapor in air. But we want to get, determine the turbidity of water is Secchi Dix. And turbidity has to do with how cloudy water is. Alright. So that is for that. So let us move further. Guys. Let us move further. So more questions that are important here. I just saw one. They said, an anemometer is an instrument for what? And I told us already. An anemometer has to do with wind speed, whereby wind vane is basically wind direction. So an anemometer is an instrument for measuring what? It's not relative humidity. Humidity is hygrometer. Alright. It is not turbidity. And turbidity is Secchi Dix. And it is not altitude. The answer is what now? Wind speed. Who measures wind speed? Anemometer. Alright, for that altitude, they use what an instrument called the altimeter. But just leave that alone. Alright, just leave that alone. Leave that alone, guys, so we can move further. I saw a question. It says, the activity of organisms which affect the survival of another organism in the same habitat constitute what? Read, listen. The activity of an organism which affect the survival of another organism. So the way an organism behaves, which affect the survival of another organism in a particular habitat, which is a dwelling place of an organism, constitute what? So this is just explain what does it constitute? Are you listening? Does it constitute abiotic factors? Anything that's abiotic are things that does not have life. But they said an activity of an organism. Sometimes an organism means that thing has life. So is it abiotic? Because they said the activity of an organism which affect the survival of another organism in the same habitat constitute what? So in summary, you are seeing organism here. You are seeing things that have life. So option A that says abiotic is wrong. Abiotic has to do with things that does not have life. So they said, okay, which factor now? Because all of them end with factor. And read again. The activity of an organism which affect the survival of another organism. So the way an organism behaves, which affect the survival of another organism, constitute which of the factors? Is the abiotic wrong? Is it physiographic? Not correct. Is it edaphic factor? No. I told us edaphic has to do with soil. Anything related to soil is edaphic factor. Be soil moisture, soil pH, soil texture, soil temperature, anything. But the answer is biotic factor, guys. The exam question. Biotic factor, because you can see the activity of an organism is affecting another organism. That's what biotic factor. Biotic. Alright? Biotic. Alright? Biotic factor, guys. All these things are very, very important. They are very, very important, guys. They are very, very important. Alright? They are very, very important. So let us answer this question. First of all, before I read the question, let me just say something. There are, in biology, what we call association. An association, they call it symbiosis. Relationship between organisms, they call it symbiosis. Are you listening? It's called what? Symbiosis. Biosis. Relationship between organisms is called what? Symbiosis. So I'm going to basically read the question so we can work on the question. It says, which of the following statement is not true of symbiosis? And I've told us already that symbiosis has to do with what now? Relationship between organisms. And option is not true. It's not true. So you can see what you are looking at for, the one that is not true about it. And I told us the broadening aspect that it has to do with relationship between organisms, right? So option A says symbionts. Then I said symbionts, meaning organisms that are symbiotic in nature. They call them symbionts. Symbiont must be living. Yes. For you to relate with yourself, you must have life. You must be living now. So option A is correct. Symbiont must be living. Class, are you following me? Class, are you following me? Let me know in the comment section. Alright? Class, are you following me? Let me know in the comment section. Let me know in the comment section. Let me know in the comment section. The symbionts are basically these organisms that are living together. So then I said, option A, symbionts must be living. Very true, because for you to relate to yourself, you must have life. Option B, it is an association of give and take. That is also correct. Alright, because some organism gains, some organism does not. That we have different kinds of, we have mutualism where both organism gains. We have commensalism whereby one organism gains and the other is not affected. Do you understand? We have parasitism whereby one gains, alright, and the other one loses. You get what I'm saying? Alright, so it's an association of give and take, very true. Option C, the association may involve two plants, correct. Alright, you know, symbiosis could be between animal, plant, animal, as the case may be. So then I said the association involves two, the association may involve two plants, that is true. Are you there? May involve what? Two plants, that is true. Alright? So let me just, before I read the last option, let me just tell us something about symbiosis. In symbiosis, it is an association between organisms that are, how am I going to say it? How am I going to say it now? The association is not organisms of same species. Are you listening? For symbiosis, you must relate with another organism of different species. Because option D here says it is an association between similar species. That is wrong. It's not true of it. Because symbiosis refers to a close, long-term interaction between different species. You will not be of the same. Mango cannot relate with themselves when I say symbiosis. I don't know if you get what I'm saying. You must be of different species. Alright, that is the point about what symbiosis, because both of them must benefit from each other. Class, hope you guys are following me. Alright, both of the organisms must benefit from each other. So look at this question they asked, alright? It says, which of these associations is much harm done to one of the partners? Alright, you know what that means, right? I told you guys, in an association, one organism gain and the other is armed. So which of the following associations where much harm is done to the one of the partner? The answer is what? They don't have to tell you parasitism. Alright? Parasitism. Do you understand what I'm saying? Parasitism, not commensalism. Commensalism has to do with one organism gain and the other is not affected at all. Or that's commensalism. Alright, that is commensalism. Note all these, they are very, very important. Note all these, they are very, very important now, guys. Note all these, they are very, very important. Note all these, they are very, very important. So let us proceed to more other areas that are very, very important here. Alright. Let us proceed to more other areas. Mutualism has to do with a relationship between two organisms where both of them gain from each other. Alright. So let us get into how am I going to say it now? Alright, so let us quickly get into a very, very key aspect in the course of this live class, and it's on what we call transport system. So let us quickly answer some questions on transport system. Meanwhile, if you are here, I have detailed lessons on my channel, like where I solved 40 chemistry and 40 biology like questions for the JAM exam. So after the live class, ensure you go to those lessons, go find them on my YouTube channel and start learning, because you might see questions that have been solved. I've done these things years ago. So ensure after this live class ends, ensure you go there and start watching them. Ensure you go there. I just saw a lot of questions here. All right, I just saw a lot of questions here. All right, so please and please go to those places and go and learn them. All right, go to those places and go and what learn them. All right, go to those places and go and what learn them. Everybody, go to those places and go and what learn them. So I'm trying to get questions on transport system, so I can basically just start right now. All right. So basically, the first one I want to ask here is, it says, which vitamin plays an important role in blood clotting? Let's say, for instance, an individual injures, all right, and the blood is bleeding. So which vitamin in our body is very, very important to clot, to stop that bleeding? It is vitamin K, called phylloquinone. Vitamin K called what? Phylloquinone. Note that. That's the first question. Vitamin K, not vitamin A. Vitamin A is called retinol. Alright? Not B12. That's called cobalamin, which could be cyano and the rest. You get. Not vitamin C, called ascorbic acid. Alright? That vitamin C is very, very important in wound healing, not blood clotting. Get it? Vitamin C is for wound healing. Alright? Wound healing. Whereby for vitamin B12, it is basically for, it is involved in what now? Red blood cells production. Alright? Red blood cells what production and DNA synthesis. Alright? For that vitamin A is important in eye vision, eyesight, and the rest. Alright, so let us move further. Let us what? Move further. Let us move further everywhere to answer more questions that are essential here. To answer more questions that are essential here. Alright? Okay. So I want to basically write this question on the board so I can analyze it together. So when I analyze it, I'll basically still basically stress another aspect. So let me wipe the board so I can write the question and then we analyze it together. So you can see how being writing the question on the board, I will use to answer other things on circulatory system. Meanwhile, after the class ends, go and watch my full video lessons. Go and just browse 40 likely questions in chemistry or biology by Nurse Brighton. You are going to see a lot of them. Just start revising with those questions because you might see it in your exam. Alright? So that is for that. Alright, I already have a detailed lesson on all these things on my channel on circulatory system. Alright? But we're going to draw the heart and show you guys things about how blood flows in the heart. Alright, they are not really hard at all. They are not really hard at all. So I would advise maybe you go to my channel to go and watch it after this live class lesson. Alright, to go and watch it after this live class lesson. I saw a question here. It says, which of the following is not a function of the mammalian blood? Alright, which of the following is not a function of our mammalian blood? Alright, I've done it already. Alright, which of the following is not a function of the mammalian blood? Option A says engulfing bacterial. Option B says production of hormones. Option C says transporting urea. Option D says distribution of heat. Option A says engulfing bacterials. Option B says production of hormones. Option C says transporting urea. And option D says distribution of heat. What is the answer? Alright, because it said which of the following is not a function of mammalian blood. Remember, the blood is divided into the blood cells, right? The blood cells and also the plasma, right? And the blood cells, we have what we call the red blood cells, RBCs for the erythrocyte, the white blood cells, also called the leukocyte, and what now? The platelets, right? The platelet. Remember, these are the components. You know, the plasma is made up of about 90% water, right? 90% of water and 10% of other substances dissolved in the plasma. Whereby, look, you can see the plasma and the blood cells and plasma that what makes up the blood. What part of our blood is involved in immune response is our white blood cells. Are you listening to me? White blood cell has different parts. We have the granulocyte and the agranulocyte, all right, which are further divided into the basophil, neutrophil, the basophil, neutrophil, eosinophil, the monocyte, lymphocyte. I have details. Let's go check that on my channel, all right. But on that, I want to just tell us something. The question is so easy, all right. The question says, listen to me. The question says, let us answer together, all right. It says, which of the is not a function of mammalian blood? Option A says engulfing bacteria. Anything that has to do with engulfing bacteria has to do with the white blood cell, all right? Because when you engulf, you are basically trying to what now? Kill all those bacteria that want to affect the individual. So it's not by the white blood cell. So it's a function of the blood. So they say which one is not a function? Engulfing bacteria is a function of the blood, but the part of the white blood cell in the blood. Option B says production of hormones. All right, no. Hormones are not produced by our blood. Hormones are produced by glands called the endocrine glands. You know what I'm talking about now. We have different endocrine glands in our body, which include the pancreas, the adrenal gland, the thyroid gland, the pituitary gland, which will be posterior and anterior. I have video lessons on my channel on all these. All right. So this transporting urea, that is true. All right, because urea will pass through our blood to the kidneys, all right, for excretion, all right, and distribution of heat, very correct. The blood also helps to redistribute heat, all right, from our skin, from the blood down to the skin, all right. That's not a problem. So all these things are very, very important right now. So I want what I want you guys to do right now, because we are going to end this live class now. So as I've said now, quickly, as soon as you are just done watching this live class, please go to my channel. Just have playlists where I've arranged all these videos, 40 likely questions in chemistry and biology. I have a lot of series on them. Go and check them out, all right? Go and check. I want to leave you guys so that you guys can relax your head. I don't want you to do too much, all right? I can actually do it till morning, but no, it's not good right now, all right? Your exam is starting tomorrow for the JAM 2026 exam, all right? Today is 15th April, and your exam is to commence, what do you call it now? Your exam is to commence from tomorrow. So you guys have to relax. So I wish you guys good luck in your exam and you come out successful. Alright? 300 plus is going to reign for sure. So just do the right thing. Go to my channel, go and check out all that video lessons, especially those I solved 40 likely questions. So you can be able to see how questions can be asked and set in the JAM exam. Alright, if you're still finding some aspect of chemistry difficult, ensure you go to those my lessons, 8 hours, 7 hours. You don't have to watch everything because your exam is ridiculous. But if you are watching this video right now, your exam is fine, you can take your time. But as your exam is closed, just try to skip and see other things I've said in those 8 hours, 7 hours lectures on my YouTube channel live. Alright? So I wish you guys good luck in your exam and God bless everybody. I want you guys, when you write your exam, you're going to score very high to be able to secure yourself your dream course. I know most of us want to study nursing, medicine, pharmacy, engineering. All these things are possible. God helped me. I've done it already. You guys can also do it as well. All right. And I wish you guys good luck in your exams. And God bless everybody. All right. So thank you very much, guys. Just take it easy. Relax yourself. Take it easy. Don't pressure yourself. Everything will be fine at the end. All right. God bless everybody. I wish you guys good luck in your exam.